I want to use this as a jump off point, this course. I also put the link in the chat. The idea here is that we're going to try to go through a couple of these items, or as much of the items as we can, but as you can see, there's a lot here going on because it's a huge application. And there's many ways to get through it and try to learn and things like that. So the way that I suggest that you learn afterwards, and I also put it here in the further learning, is to use Unity Learn, which is at learn.unity.com. And they have these learning paths, like the Unity Essentials. That's pretty good. Although in the beginning it's pretty slow, so it takes some time to actually go through them, but it makes sense. A lot of these tutorials are like that, which is a bit unfortunate, but yeah, that's the way we have to do it. So the first thing that I want to talk about, so this is my agenda for today, is about, okay, planning your game or experience or whatever it is, and then also talk a little bit about what Unity is, some essential concepts, how do we get started, so how do we create a project and things like that, and then once we are in a project, like the user interface. Are there people who have never opened Unity before, etc.? Okay, so it's really important that we go through this as well. And then how do we build a level? You'll see that we don't actually have that much inside of Unity, so we really have to bring in our assets, and we'll use some modular assets that we get. And then we will talk about, okay, now that we have our world, how do we move inside of that world, and explain player movement. And then we talk about, okay, how do we, now that we have our basic world, how do we change it? So how do we set materials? How do we light the scene? How do we add audio to just amplify that mood? And then there's a bunch of other things that we probably won't get to because it's too much. There's some animation, procedural animation that I want to do in the beginning. Talk about physics, maybe we can also already do that in the beginning, that as part of our first project. And a little bit of scripting, but just tiny bits. And then if we want to publish, this is really important, if we want to actually do something with it, how do we work with that? So what is a project? What is a scene? What's the difference between the two? How do we publish this to either the web, or how do we publish this to iOS or Android or things like that? And then I also want to cover future possibilities, because if you come away from this tutorial just learning about all these basics, you think that this is always the way that you have to make your level, which means that you have to do it by hand, placing every object yourself, and that's not true at all. You can actually use procedural level techniques so that you basically build your level, or let Unity build your level through scripting or coding, or plugins like Dungeon Architect. And there are some tools for AI at Unity Machine Learning which are also interesting. So that's it. I want to start here maybe with what is Unity. It's also on Unity Learn, there's much more about it, but really shortly, it's started out as a game engine for a game that they built themselves called Kerbal. It's a Norwegian company, I think. And they started building their engine together with the game. And then they found, well, there's a lot of people actually building engines. Why can't we just build an engine that we can sell to other people? And that's what they did. And so it started out as a game engine, but it's not just a game engine. There's actually much more inside of there, where it's used, for example, for things like architectural visualizations, or medical operations, or medical systems where they actually do training inside of that virtual world, or allow people to have like a virtual catalog where people can browse through those things. So they don't really call it game engine anymore, they call it a real-time engine. And so to talk a little bit about that aspect of real time, the idea of real time is that it's something that happens immediately, so like 60 frames per second on your computer. This is in contrast to something like Blender, where you have a scene set up and you do the processing of that scene not in real time, but beforehand. So you render your whole scene, and that takes a while, from a couple of seconds to minutes to hours to days. To actually render out your scene, and then once you have that scene rendered, you can make that into a video and play that. But it's not real time. Changes you make don't immediately happen in the engine. And so in Unity, most of the stuff that we do or almost all of the stuff that we do is real time. There are some exceptions to that. Lucas, can you turn off your mic?
Oh, sorry, my bad.
So that's a big difference between real-time and non-real-time or generated content or rendered content. And then it's also important to talk about what it does not do. So because coming into Unity with the idea of I'm going to make a game, of course that's the whole purpose, but you'll immediately find that once you start creating a world, there's not actually many things there to actually create a world. That is, there are no models or whatever inside of Unity by itself. As you can see, it's mostly blank. There are some basic primitives that we'll use, but after that, there's not much more there. And that's because Unity is basically the place where everything comes together. I actually had this here. So this is our game engine. It's basically where we take in our 3D models, our textures, our audio, scripts that we have, animation, 2D sprites, and we all put them inside of our game engine. But the game engine, so this is Unity in the middle, but the game engine itself does not create 3D models. Now, there is some, with new tools, there is some blend over. There are some tools inside of Unity to actually do that, so it's not really clear anymore. But for most of the time, that's what you're going to do. So you build your models beforehand in, for example, Blender, or you download them from somewhere, which is what we'll do today. And then you bring those into the game engine as assets. And then you do the same thing for your textures, for audio elements, and then they come together in the game engine itself. So Unity doesn't do that. And so I refer to other tools like that. So for 3D, for doing models, environments, you would use Blender or Cinema 4D or Maya, but probably Blender. For 2D, so if you make illustrations or backgrounds or textures, you would use something like Photoshop or Illustrator. If you want to add audio to your thing, well, you can start recording audio, and then you take that into Audition or Audacity or Ableton Live, Logic Pro, so any kind of audio application. And then if you want to do coding, that's also not built in, and then you would use Visual Studio. So I think the moment that you install Unity, it also asks you to install Visual Studio. If you don't have that, that's fine. I'm also on PC, so it will look a bit different. I will just use Visual Studio Code. The downside there is that it doesn't do auto-completion, but that's fine. And then there are some showcases that I want to do just to show you, and that's why I wanted to check the video. So I want to play this short video to show you some of the games that are made in Unity. So hopefully it's clear from this demonstration that there's a lot of visual potential within the way that you can make games, so they don't have to look all the same. But it will take some effort to actually make your game look non-standard. So we will see that there's a lot of extra work that needs to be done to make something that doesn't look like the default cube. But yeah, we can do that. All that violence, yeah. Indeed. Lots of shooting and opening up limbs and tearing off things. But yeah, shooty things. We don't have to do shooty things. Um, all right, so I want to talk a little bit about the essential concepts within the game, and then quickly go through them, and then actually do that inside of Unity itself, because it makes sense to do it there. So there are a couple of really essential concepts that you have to understand, and the first one is game object. So whenever you're in Unity, everything that has a place in the world is a game object. So everything that's in your scene. And game objects are shown as a list, you will see that. And they also have a hierarchy, so that means that you can have a parent and a child game object. And we will use that throughout the whole system. It's very useful. You can use it for grouping things, but also for moving things together, for example. And then a game object by itself doesn't do very much. It has to have components to actually do something. And those components are things like a mesh that's attached to it, which is a mesh is like a 3D object, like the shape of a 3D object. But it can also be a sound, it can be movement, it can be a script, it can be audio. Those are all components that are attached to that game object. So by default, the game object only has transform, it only has a position and a scale, but it doesn't have anything else than that. And then the components themselves, those are actually the bread and butter of Unity. There are a lot of components that are built in, a lot of them that you can also install through plugins, but you can also make your components yourself by using scripting. And a component, you will need it immediately. So if you don't want to have a completely empty world, you need components, because those are actually there for doing things like putting a mesh on screen, putting a box on screen, for example, that already needs 2 or 3 components. And then you can add and drag components. We'll do that. And then once you have those game objects and you have created them in hierarchy, what you also want to do, and we'll also do that today, is to make prefabs. And prefabs are make Unity actually really powerful, because they allow you to do things like building a modular world. So you don't have to do everything from scratch over and over again. Instead, you make a prefab, and a prefab is a pre-configured game object. So it's a game object with all the settings and components stored inside of there. And so once you have that prefab, you're going to drag that, so it's in your project folder. You can drag that in to your project, and then you create an instance of that prefab. So it's not really a copy, because with a copy, nothing would change, but with an instance, the moment you change something in the prefab, it changes in the world itself. So for example, if you make an apartment building as a prefab, and you change the colors of the apartment building in the prefab, it will change everywhere where you use that apartment building. Or if you increase the size of the windows, you will see that everywhere. If you change something in an instance, it doesn't automatically change that in the prefab. So you can do these what are called overrides, which is like, okay, I want to use this prefab, but I want to give it a different roof, for example. So I want to use my apartment, but now I want to change the material of the roof, for example. And that's called an override. So that changes the prefab to a more unique version of that prefab. And then there are all these tools where you can say, well, now I want this for everything. It looks better this way. So you can apply that and then it gets stored in the prefab. But we'll go through that as well. There's lots of documentation on that. But this is useful because it makes building levels so much easier. And then you have layers. They don't work like Photoshop, but they're quite important, but I'll explain what they are. Assets and tags, and I think for those things it's best to actually show that inside of the application itself. So the next part that I want to talk about is the installation. You should already have that, so I want to go through the user interface, but for that we need a project. So what I'm going to do is in a minute we'll build this beautiful project, which is like a rolling ball game. So you can see that we have a ball here and it will roll down the hill, and then it's not actually interactive, so it's just doing its thing, but I'll show you how that works. So to do that, what we're going to do is we're going to start Unity Hub first, and you can follow along. And here in Unity Hub, in installs, you should see your version, like the versions that you have installed for Unity. And so in my case, I have 2020, and then I have 2019 as well. You also note here at the bottom that I have this icon here, which is the build support. So whenever I install Unity, it's going to ask which modules that I want to install in addition to the Unity itself. So I have Visual Studio here, which is the code editor. Again, that's not something that's built into Unity. And then I can choose all these platforms where I want to build for. So I can choose to build for Mac, for Windows, and then here I choose WebGL. And WebGL is basically for building it on the web. So that's useful to have. And then we'll also deploy that so you can see an actual game in action built for the web. So if you don't have that yet, it might make sense to actually install that as well. So again, you take your install, here in installs, you go to modules, and then you can install WebGL, and then click next, and have that installed. All right, and then here there's some other tabs. The learn is actually really useful to learn these things. They heavily promote this Lego micro game, which I did. I have sort of a mixed feeling because they also, the thing itself introduces a completely different system from Unity, so I don't think it's that useful. I like the other ones is better because this one is already maybe too specific. But we'll just start from scratch. So here in projects, what we're going to do is we're going to make a new project. And here, if you have multiple versions, you can actually choose which version you want to install. So I'm going to use the 2019 version. And then I get this dialog box with all the versions. Do you actually get this as well? Are you following along?
Yeah, I see it.
Okay. So there's a bunch of, let me close the window. There's a bunch of templates, they're called, basic setups that I can use, like the Lego micro game, for example. There's 2D, 3D. All of these are actually starting from the same thing. So if you choose something that doesn't make sense later, then that's fine. You can always switch back. So even if you choose a 2D world, you can always move back to a 3D world. It's just how the camera is set up. So that's not really a big issue. But now we're going to choose 3D, like an empty 3D scene. And then we're going to give that a name. Recently, Unity also has set up this, what is called a universal render pipeline, which is a more complex version of how things are rendered just to make the graphics looks better. It's also much more complex, so we don't cover it today, but it's interesting to look into later because it allows lots of the tools that you also see in Blender, for example, using nodes to build your materials, which is super awesome. But now we're just going to use a 3D one, and I'm just going to call this project Code Studio. What's really important here is the location. So I have a folder, so I'm on PC right now. I have a folder in my documents folder called Unity, and inside it will create a folder called Code Studio. You'll see that using the file system or understanding what happens on the file system level, it's actually quite important because Unity maps one-to-one with what's in your files, right? So make sure that you know this path so you know where it's stored because we'll need to access that later. So I'm going to create that, and then that's going to import these basic assets, which in our case is just a camera and a light, and that's it. And once we have these assets, then it's going to open Unity and then show me that scene, and then we can actually start navigating inside of that scene. It helps a lot if you have a mouse with multiple buttons, like a proper right mouse button, because a lot of the tools actually use mouse buttons. You can do it on a trackpad, but if you have an external mouse, it works much more comfortable.
Frederick, I have a question. I want to make a new project, but it constantly gives me 2020 instead of the 2019 version.
Okay. Can you, in Unity Hub, use that little arrow on the side?
Wait, little arrow.
Okay, let's go back. So in Unity Hub here, I have this little arrow here next to new. And here I can choose a version.
Yeah. Uh-oh, sorry.
Does that work?
Wait. Oh, okay, yeah. Sorry.
Yep. All right, no problem.
It was a 3D, right?
3D, yeah, just a basic 3D thing. And you can see the version here as well. You can actually switch later as well, but this is not recommended because there's some features that are, of course, are in the newer versions that are not in the older versions. So going back to previous versions is actually not a good idea because it will break a lot of things.
Mm.
That's still quite messy. So I'm happy that they have the LTS version, which is the long time support version. So they actually have a version that you can use for a longer time without things constantly breaking, which was a problem in the past. All right, so I have this basic layout. You will have something similar. There are some tabs here, and I'll just go through the user interface so you can see a couple of these things, so what I mean actually. So here at the top I have the menu, which is kind of important. On Mac the menu will be just in the menu bar, but we'll use these settings here. Then we have this little toolbar here. This toolbar is actually also accessible using the keys, using the QWERTY keys on my keyboard, and I'll explain later what they do. Here are some settings for changing grid snapping, which we'll use later. And then this is the hierarchy pane. So here you can see all the objects in your scene. This is so convenient. And then you have your scene view. So this is where you can actually see everything that's going on. Once you select an object here in the hierarchy, like the main camera, for example, so if I click here, I can see all of its properties in the inspector. So the inspector is basically the place where you change all the properties or the values of that object, specifically of the components of that object, because you can see these are actually components that are attached to this object, like the transform components, the camera component, and the audio listener component. And we can add more components. We'll do that later. And then here at the bottom, you have your project. So this is, as I said before, a one-to-one mapping with what you see on your file system. So here I can right-click, for example, and then show in Explorer or show in Finder on Mac. And then I can actually see the same thing that I see here. So I see in the assets folder, so I can see scenes, and that's the scene that I'm actually looking at right now. And then if I add more assets, I can just add them immediately here in the Finder, or I can add them here with importing a new asset. So this is important. Now, as you can see, we don't have any assets. So if we want to make a new object in our scene, we don't actually have anything to work with. So we have to use the built-in assets. But later on, we'll actually use the some imported assets that we get from somewhere else. But right now, we're just going to work with some of the built-in assets. So the assets that they have are called primitives. But first, let's make one so we can actually have something to move around. So we're going to go to Game Objects, go to 3D Object, and then choose a cube. We have to start with somewhere. And then if all goes well, you would see your cube here, and then you'll have in the inspector, you'll see all the items of the cube. And here on the hierarchy, you also see the cube selected, right? Stop me if there's something that's happening differently in your case.
I'm still opening the project. It's showing the splash screen. Yeah, so I'm just waiting. I hope it didn't crash or anything.
Ah, yeah,
So.
okay. Yeah, let me know if it works for you, because sometimes it takes a while to get started. All right, so we have our cube, and what we can see here is that we have these values. So we have our position, our rotation, and our scale. And we see also that we have these handles here, so we can drag these handles around. For example, we can drag here on this red axis, and we can see that we actually move this in the X position. So we can see that we move the object, obviously, and then also this value, this X value here changes. So this is at 0, 0. And then we can also type a value like 8, for example, and then it moves to that position itself as well. Of course, you can do the same for the Z axis and same for the Y axis. And these are already really important. Note that the Y, so in 2D, X and Y are the primary axis. Here we move our object in the X and Z direction. So this is actually moving in X and Z, and Y is up. So Y in this case is up and down. Another important part is that you can, when you move an object in 3D space, if you just drag it around, it's kind of hard to tell where it goes because we move all of these values at the same time. So Unity has these controls here that make it a bit more convenient for you. One, you have these gizmos, they're called, the handles for all of the different directions. But also you have these little cubes here, or these little planes, and these actually move your object into two of the 3 planes, so not all 3 at the same time, because you don't know where it is because you're in 3D. So for example, if I click this lower one, I'm moving in the red and blue axis, which means I'm moving in the X and Z plane. So you will see, if I set the Y to 0 here, you will see that the Y doesn't actually move. It's just moving X and Z, which is very convenient because that means that I can have an object that stays on the ground, for example, but I can move it wherever I want on the ground without actually affecting the height of it. So I'm happy that they added this. You can also enter values here, as I saw before, but what you can also do is you can drag. So if you move your mouse over the letter X here, you can drag this up and down, or left and right, sorry, and then it's going to move along that axis. So it's always dragging left and right, even though the thing itself is moving up and down. That's not really important. You just have to move. Oh, you can actually do it this way as well. That's cool. And then same for Z, of course. And that same applies for rotation. So you can rotate in this direction, the X direction, the Y direction, and the Z direction. I have to confess, I'm always confused which one there is. There is a system for learning that, but I just try them out, all three, and see what happens. And then you can do that for scale as well. Notice that we have these tools here. So by default, we're on the move tool, which means that we can move our shape here. There's a rotate tool as well. And so if we click it here, we can actually see that we have the same handle. So this blue, green, and red handles that allow us to drag objects in these three angles. So moving in the blue one moves this in the Z direction. So you can see I can move this around. Moving it here moves it in the X direction, moving it here, and the green one moves it in the Y direction. You can also drag this wider thing, and then just it moves everything. It's sort of confusing, so I like to do it one at a time, because otherwise I get confused which one I drag. And then finally you have scale, and here you also see you have these three gizmos, so you can scale in one axis if you want. Or if you drag the one in the middle, you can actually scale all axes at the same time. This one is used more for 2D. You don't actually use it in 3D. It allows you to change the properties of an item, so the scale and the position at the same time, which is convenient in 2D, but makes no sense in 3D. And then this is basically the Uber gizmo that brings everything together. So it does and scaling and moving and rotation, so you can do all of them at the same time. I just use the basic ones, and the reason why is because I use shortcuts for those. So I have a QWERTY keyboard. Hitting the Q key will actually give me the hand, so the first option, which allows me to drag around the scene. Using the W key allows me to get the move handle, so I can move my object around. Using the E key gives me the rotation, and using the R key gives me the handles for scaling. And that's really convenient because that's right under my left hand. So my left hand stays at the keyboard and just hits these buttons. So I'm really quick with moving these shapes around. And you'll see me do that instead of just trying to hunt for the right icon here at the top, which is much slower. So this really makes sense from a shortcut standpoint to actually learn these things, because it makes it easy to move things around. Any questions so far? Lucas, is it loading still, or?
Yeah, still loading. This is really weird. I'm pretty sure I opened something yesterday, but I don't know. Anyway, I'm not sure what's going on. I'll delete everything and then try again.
Yeah, you could try force quitting and trying again, because this is really like the most basic scene that you can have. It's not that there's a huge of stuff that's going on. Yeah. Other people, does it work for you? You can move things around and scale them and stuff like that. I can't actually see you, so okay. Yeah. All right.
Yeah.
Great. So then what we're going to do here is we can reset the transform. So if we have played around with the transform and you want to reset everything, you can click these little three dots here at the side and choose reset. And that's going to set everything back to 0. So we don't have to manually type 0, 0, 0. Note that the scale itself is not set to 0, it's set to 1. So a scale of 1 means 100% of the default scale. So 1 is multiplied by 1, because a scale of 0 actually flattens this object down to 0. It's like multiplying the scale of the object to 0, which means it's multiplied with nothing. So there's no object here. Also notice that these values are actually quite, or can get big quite fast. So a scale of 5, for example, or 10 already makes this huge object. The way that you think about these scales, or the way that I think about these scales, is you can think of them as meters. So a position of 1, for example, is 1 meter. So a cube of 1 by 1 by 1 is a cube of 1 meter. So if you want to make a character that's 2 meters tall, you would type, you would use a scale of 2, and then you probably move it up 1 meter, so it's at the ground level. All right, and now it's time to actually learn how to translate or move to our scene. So for that, we use the Alt key on our keyboard, or the Option key. Now we get this little eye, and now we can drag with the left mouse button. We can drag around the scene, and we can actually see it from all of these different angles. So this, of course, is really essential for looking at your scene and seeing if everything is there where you expect it to be. So this is with Alt and the left mouse button. Then Alt and the middle mouse button, or the mouse wheel, actually moves the scene around. So you have this little hand. Note that you can also have it if you click here, and you can drag this around, but it's much faster if you leave these tools selected and you can just move around like this. If you don't have a middle mouse button, you can also do Alt and Control, and that also moves the scene around. And then finally you have Alt and the right mouse button, and that's going to zoom into your scene like this. But you can also just use the mouse wheel for zooming in and out. That works as well. So again, in my case, Alt and the left mouse button is going to move the mouse around. Alt and the middle mouse button, or the clicking the mouse wheel, is going to pan like this. And then Alt and the right mouse button is going to zoom in the scene. Or you can also do that with the mouse wheel. One other useful shortcut, and for that we need one more object. So I'm going to make another cube. So I'm going to go Game Object, 3D Object, and then maybe not make a cube, but like a cylinder. I'm going to take this cylinder and move it somewhere else. So move it off screen here. And now what I can do is I can hit the F key, and the F key is like for frame. It's going to take the object that you've selected and frame it in the view, so you can see it in the view. So it's not rotating your scene, it's just moving your view so that, and zooming in your view so that the object is selected. This is really, really convenient. Again, it's under your left hand, so it should be a key that's just that you just immediately hit. The F key is also the one that has a little indent on the keyboard, so it's really easy to find. So this makes navigation really fast, because if I now select a cube either by clicking it or selecting it in the hierarchy, I can just type F and it immediately jumps to that object itself. And then most of the time I like to zoom out a little bit, or get the cylinder here. If I have two objects selected, so if I hit the Shift key and then select two objects in the hierarchy and now hit F, I should be able to see them both at the same time. Although maybe not. What? Apparently this only works if they're parented, but we'll talk about parenting right now. Give me a sec.
With me, it works.
Okay, thanks, Lucas. Yeah, and with the F key?
Yeah.
All right.
Weird.
What? Yeah. All right, so these are really the basics ways of navigation. So try navigating around your scene a little bit, just to get a feel of how that works. Maybe add another object. You can also just copy and paste objects. So you can hit an object here, hit Control-C, Control-V, and then the object is copied on top of the previous object. So you can have that object and move it around the scene. So you can drag it here. And you'll note, because you're in 3D, that it's really important to understand what these handles do, or move an object around in 3D space, because you want everything to sort of be on the ground while you're doing that. Otherwise, it sort of gets confusing. And again, try hitting the F key, selecting another object, going there, and something like that. All right. That's the basics for navigating around our scene, and those really are used all the time. So it's really important to understand what they do. Another thing that, any questions for that first? No?
We're just setting up objects here and there, right? I didn't miss anything. Okay.
No, we're not doing anything crazy yet.
Okay.
It's just for understanding a little bit of the basics of these objects, and we'll delete them in a minute because we're not actually that attached to these three objects here. Another thing that we can do with these objects is we can parent them. So by parenting, what I mean is that we can take an object and have that object be the parent, or the top object, and the other objects be the children or the objects that are below that. And this is really important because they allow you to move things around. So I can take this cube here, take this other cube, I'll move it a bit closer to this one here. Maybe also make it a bit smaller because it's the child, right? And then I can drag this cube inside of this one. So I drag it over, you can see that it's highlighted. And then this cube is now parented, or this cube 1 is now parented to this cube. Which means that if I move this cube around, now the other cube will follow. Right, so that's the idea of parenting. Just to give you a quick idea of how you want to do that. So for example, so you select this cube, you do right mouse button, you select 3D object, choose a sphere, drag that sphere up. You'll see that it also takes the scale of the parent item, which is in this case not really what we want. But we're going to drag this down, and now we can create our little guy here, which is just our cube and a sphere. And for some reason, this weird thing that's following them around, like a backpack or something. Yeah, let's make this a backpack of the guy. Right. And it's kind of to the side here. Right. Beautiful. So now we have our little dude here, and now if we move him around or her around, we can see that we actually drag all of the objects at the same time. And this is really convenient because this allows us to not just move everything individually all the time. So this is a parenting. You can drag objects around wherever you want. So if you don't want the backpack anymore, which is this one, you can drag that out. So you can take that object and drag it somewhere else. You see this blue line indicating where the object will be dragged. So I can drag it here. And now if I drag this cube again, the other object won't follow around anymore because it's no longer parented to that other object. Everything can be parented, even the light, even the camera can be parented. So if this guy is actually our main character, we can actually take our camera and then attach that to our cube, reset the position of the camera. So go to the camera, select the camera here, go to reset. And now the camera is actually part of the dude, right? So it's dude is looking through the camera and probably want to look through his head. And also with rotate, actually rotate the camera around so you can see what we are seeing. So we see that our camera, we see this little trapezium coming out of it, which is called a viewing frustum. So what is the camera actually seeing? Because this is a perspective camera, it goes from a small version to a larger plane. So we have this small plane, which is our eyes basically, and then we have the larger plane, which is where we're looking at. And now if we move our little dude around here, we can see that we actually see through the camera. So the camera is moving along with the little guy. Does that make sense?
Yes.
Mm-hmm. So everything can be parented. This is actually used very commonly if you're making a first-person game. A lot of times you will have your player here, and then you will have your camera attached to it. Now, I'm kind of annoyed with the names here because these are all just called cube and sphere and cylinder, but we don't actually know what they are. So Unity doesn't really care, but we actually might care, so we might want to change these names here. And we can do that in the inspector. We can change the name here. So instead of cube, we can say guy, for example, and now that becomes our guy. And then here instead of sphere we can say head, for example, and then that changes the name. It doesn't do anything else but change the name, but it's important to know that we can do that. All right, so we are also going to get our backpack here and then attach that back to our little dude. If you have a different setup, that's fine as well. It's not really super important how that's going to look. Note, and this is probably intuitively makes sense, but it's still important to note that if we now move our backpack, the dude itself, the guy itself, doesn't actually move. The backpack moves now in relation to the guy. So these positions are actually called a local transform. So these are the local values, not the global values that are applied to the whole scene, but the values in relation to the position of the guy. Because so for Unity to calculate where this thing is, it actually has to know where the guy is in the world, and then it has to add the value of that backpack on top of there. So this value actually changes if we drag it here, and you can see it. These values actually now are global values as well. So these positions change because they are now attached to the whole scene instead of the backpack. So you can see the position here change if we move it to the guy. You can see that the position actually is now smaller because it's now in relation to this central object, which is this guy. So these values, because the object stays in the same location, but the backpack itself is now attached to the guy itself. All right. So that's for moving him around. There are some other properties here. There are some tags that we can set. The tags themselves are used inside of games specifically. If we're doing programming, for example, we might have a couple of these tags set so that I can find objects with a certain tag. So here in Essential Concepts, for example, imagine that you have a list of all the enemies in your game, for example. You might all tag them as enemy, and then you can say, well, select all the game objects with the tag enemy and now move them towards the player or something. So this is a way for having objects so that it's not just a name, but actually an extra parameter that we can add to that object. And yeah, you can change them like this, but we don't really care at the moment. Same goes for layers. Layers are also a way, not really to group things, because that's what this hierarchy is for, but it's a way of basically allowing the Unity to figure out when to render certain things. So you see that the names are also not names that you would see for layers in Photoshop, for example. They're not like that at all. So this is like a layer for transparent effects. This is a layer for ignoring ray cost, water UI, and things like that. You can think of layers as sort of like visual rendering that has to happen on top. So the UI, for example, is a layer that happens on top of the game itself. So you have the game, and then you have the UI, the interface of the game, like the health bar, for example. I don't know, in a typical game, that's on top of the played level, and so it's somewhere else. It's not necessarily attached to this 3D scene, because then the UI bar would constantly have to move the moment I move my scene around. So instead, it's on another layer that's on top of the scene, like a 2D layer. We'll also add a post-processing layer later. And then here as well, in the inspector, we also see all of these different items. These are called components. So we have the transform component. You see I have these little arrows here, so you can open them and close them down. We have our cube component. So this is our mesh, basically. But this is actually in two parts, and it's kind of confusing, I think, but that's the way it's set up. So the mesh filter is basically, okay, what is the actual shape of the thing itself? So what is actually the what's called the mesh, or the 3D object that's there, like the points of the object. And then you have the mesh render, which is how do we render this object. So these are separate. We can turn this off. Let's turn it off for the guy, for example. If we turn off the mesh render, you see we don't have that body anymore, because the mesh itself is not rendered anymore. And that mesh gets rendered with a certain material, and that gets linked here, and we'll do that later. There's some settings for the mesh render for how to apply lighting, which lights should affect which objects, whether it should move, and things like that. And then there's another component that's attached by default, which is called the box collider. And the collider is basically how it relates to things in the world. So if this object is inside of the world? Does it fall down? Does it hit other objects? So this is for physics. And then here we have that default material that came back here. And then we can add our own components here as well. So for example, we don't do it here, but for this cylinder, for example, we can say, well, add an audio component. Let's add an audio source. And now if we have an audio, which we don't, then this object would make a sound. So this is a way that we can add components here. And then there's all these options for like how the sound is influenced in the world and things like that. So we're going to remove that component here. But these are used all the time. So adding components to a scene is very, very common. All right. Thinking if there's anything else that I'm missing. So layers, assets. Yeah, maybe we should make a material here. So we're going to build a very basic scene I just showed you before, the lava world, where we have this rolling ball, this ball rolling down the hill. And to do that, we're going to have our little observer here who can't actually do anything to influence the scene, so it's kind of a pity. But he's going to look at this lava world that we're going to build. So to do that, we're going to make a couple of long cubes, and then we'll have a cylinder roll down these little hills here. So I'm going to delete this cylinder. And I'm going to create a new game object here inside of my scene. So I can do it here, or I can do it here. I choose game object 3D, and I'm going to choose a cube here. Cubes are always useful. And then here for the cube, what I'm going to do is I'm going to use my scale tool. Again, I can use the Q, W, E, R keys to scale that up. And I want to make something like a long stretched out plank. So I'm going to make it a bit thinner, a bit wider, and then this is going to be my my platform basically. So I can move that around. I'm also going to move it a bit in the X direction. Actually, I leave this here in the X direction. I want to set this to 0, but I'm going to move my guy back here. So this actually moves here. So my guy's looking at the world, but he's actually a bit further down the world itself. So it sort of looks like this, right? All right, and I'm going to make a platform here. I'm going to copy and paste that. I can also use Control D to duplicate an object here. So I hit Control D, and now I can move that up like this. And then I also want to rotate that object. So I'm going to go to the rotate, change the red angle here, make another copy, move that, change the rotation a little bit like this, copy, move that, like this. Maybe I move it here and then rotate in the other direction. If I lose track of the object, I can hit F to actually zoom into that object and then move that around like this. All right. Let's see. So this is my very basic scene. Maybe this one can be a bit longer. So I hit E and then drag that out. And then here I can drag this in two angles by hitting these little squares here, conveniently placed at the right location. And all right, that looks good. And then maybe make that bottom platform a bit wider so we can catch the ball. All right, and so the basic idea is that the floor is lava, so we don't want the ball to fall on the floor. And where is our ball? We first have to make our ball, so we're also going to create a sphere, 3D object sphere. Check if that sphere is actually in the right position. It seems that it is. And then we can hit the W key and then use a red square here. Oops, not that one. Use a red square here to move that ball in the correct position. As you can see, it's here on top of our little plane here, which is where we want it to be. Again, we can hit F to make sure that it's actually where we want it to be. I'm sort of annoyed that it's not exactly here. Okay, whatever. Right, so now if we hit play, and so now we're in edit mode. If we want to see our game in action, we can hit play, and this will actually play the game. So now we can see what happens if we play the game. And as you can see, nothing happens. Our ball doesn't actually fall. We don't actually see our ball even. That's because our camera is not linked to that. But we have to do a couple of things. So first, let's move the camera here. First I'm going to ask a question. Is everybody with me so far?
Yep. Yeah, I just didn't, I think, attach my camera. Did you attach the camera to your guy? Is that what I understand?
It's inside of this guy here.
Mm-hmm.
And then what I did is with the camera transform, I do reset, and that's going to reset the transformation. So that means that the guy itself is, like the camera position is related to the head of the guy in this case. So I moved it a little bit. It's not really necessary, it's just to make a point, but we'll use that later, so it might be useful to actually learn how that works. Note that if we click the camera, we can actually see a preview of that camera here, which is really convenient.
Yeah.
But Lucas, for the rest, you were able to make the scene here?
More or less, yeah. I just have to make the ball on top, and that's it, if I'm correct.
Yeah, I'll give you some time in a minute to explain.
Yeah, sure.
So to make sure that we can actually see the scene, what we need to do is actually move our camera up. So we're going to select our rotate tool here, use the red key here, and then we can drag up. So now the guy is looking up towards the scene, and I can actually see the ball. As you can see, nothing's happening because the ball itself doesn't actually have the correct component attached to it. So here I'm going to select the sphere, choose Add Component, and now the component that I'm going to look for is in physics. It's called a rigid body, this one. And this is a body that actually makes the ball move. So all the other objects have these box colliders, which means that the objects are available for colliding. If we don't have that box collider, the object will just fall through because it won't be part of the scene itself. But with the sphere, which is also a collider, also has a rigid body, which means that it moves. So things that are just in the scene with just a collider are static. They don't move, but they are there to be able to detect collisions. And that's an important difference. So if you have some background elements, for example, that don't influence your scene and they don't influence the physics, they don't have to have colliders because they're not related. They won't collide anything. So Unity doesn't even have to check that the ball will collide against them. All right, so now if we hit play again, we should see our ball actually move down our little hill. And we saw that it fell down. There it is. Now it's sort of falling down. Yay, cool. And then, of course, it will fall off the world because there's nothing there anymore. But that's cool. Maybe it makes sense for a guy to be a bit up, so a bit higher, so you can actually oversee the scene. So I'm going to take my guy here, move him up, maybe move him a bit further, check our camera. And now take our rotate, and then rotate it down so you can actually see the scene a bit better. So move it here. That makes sense. Now if we hit play, we can actually see a bit better where the ball is actually moving. Yeah, that makes more sense. So this is really useful in Unity because it's really easy to make these physics installations or setup that are actually quite quick to do. Another fun thing that we can do, but it's a bit more involved with scripting, so we don't do the whole thing, but you can think already of something where, for example, if you hit an object like this, you can add this in the box collider, you can say is trigger, and now you can add a script that whenever the box or the ball or something else hits that object, this triggers something, and that trigger can then, for example, start playing a sound or something. So you can have your musical installation with lots of balls falling on these panels and then actually have that affect something. So even though it's very simple, you can already do a lot with that setup of physics. All right, so another thing that I want to add here is my lava and basically style the world a little bit. So I'm going to make a 3D plane, so 3D object plane. And here for the position, I'm actually going to hit reset, so it's actually at the ground level. And then I'm going to increase the scale. So again, move to the scale tool and then hit the middle scale icon and then just drag that all the way up. So something like 20, for example. If you're really want to make sure that it's 20, you can just hit the values here as well. So 20 tap 20 tap 20, but yeah, and you can also just drag it up. Now everything sort of looks the same because it's all the same material, but here we want to use our lava material, so we're going to do that as well. All right, and for that, we're actually going to go to the Unity store and get a material because we have some specific materials in mind. So we're going to use a free material that we can use. First, let's save our scene here. So file save. It could be that it's asking you where to save the scene, but by default it's saving here. The default name is sample scene, which is not the best name at all, but we'll leave that as is for now. Okay, everybody with me?
Yep.
Yes.
Yep. Yeah. All right. Am I going too fast, too slow?
No, I think it's fine, at least for me. Oh, you said you pressed a reset. Where was that? I wasn't looking at the screen at that point.
So let's do that again. So if I make a game object, if I make a game object like a 3D object plane, it's just going to move that in the center of the view. So wherever I'm looking at, as you can see here. So the position is already set to these weird values, and if I drag around, I can see it's not really where I want it. Now, because I'm always working from the center, I know that I want to have that here, so it's at the bottom basically, this plane. And now I can use the scale values to actually increase that scale. So I often use these values, the numerical values, to actually place objects in the scene. At least initially.
So it's precise. Yeah. Okay.
Yeah, so it's precise indeed. All right, so now I can go to the asset store. So you should have a tab here called asset store. It's not the fastest tab because it's actually loading a browser inside of this other thing, but that's fine. And what we're doing here in the asset store, so Unity has all of these built-in assets, or all of these assets that you can have for sale, where you can have these things built in. So for example, if you just want to build a fantasy game, you just click here, you buy the thing, and then now you can make fantasy games. So like a terrain scene generator. These are actually sometimes really, really good. So I have bought a couple of them, and they're really useful to have, like skyboxes and things like that. For now, what we're going to do is go to assets here at the top and select textures and materials. And we're just going to look for free assets. So here on the side, we can choose for pricing. We can hit free assets. And now we only see assets that don't cost any money. And we're looking specifically for this one, UGIS free ground materials. So I already have it, but you can click here. And then you can click the, I think it's download button first. And then once that's downloaded, you can click the import button. So I'll let you do that because it will take a while to actually download that.
Are there any restrictions or, like, let's say legal copyright problems if you use free assets, or?
No, well, you definitely need to check the license, but I think all the ones that you buy are actually there for using for commercial purposes. That's a bit the point of the whole thing. That's why you buy them. And for the free version, they're free for everything. I think you can use them in commercial applications as well. The only downside is because they're free, you will see them everywhere. So once you start using them and you play other games, you will see these assets over and over again because everybody's using them. It's kind of funny sometimes. So if you download them, you can hit import, and now you can see that it's importing the assets of that package. And you will see a dialog box that looks like this, which is all the assets that are inside here. So you can basically pick and choose which specific assets you want to import inside of your world. So if you want, most of the time you just select everything because you want all the assets here. But for example, you can also say, well, I'm only interested in the lava ones. So you can click none and then just select the lava folder, and then you only have the lava. In our case, we'll just select everything because we'll need a bit more than that, and then hit import. What's also important to know is, again, this maps one-to-one to your file system. So now in your project, you will see that you have your assets folder, your asset project here called ground and textures pack. You can open that up, and now you can see all of the different things that we imported, like the lava, for example. And now you see the textures of the lava here. And you also see them in the file system. So if you right-click here on an asset, whatever asset, doesn't really matter, and you do show in Explorer or show in Finder, you can see that you have that asset here. So again, I have this Code Studio. This was my project. I have a folder assets, and this is the ground textures pack that I just downloaded and imported. And inside I have all these files. You will also see that all of the files actually have these .meta files. This is an extra file that Unity adds just to make sure that it knows about the asset. This just contains the last time it imported and things like that. You just have to leave these here. And so here you have these lava textures here, and you have the preview. So these are files, right? You can just look at them. All right. Does that work for everybody? Imported the asset?
Yep.
Yep.
Cool. So now you can go back to your scene, and now we can actually apply these. So we can go to our assets, ground and texture spec, if you don't have that yet, lava. And then I have a couple of these. So which ones do I have to check? Which ones do I need to use? So this one, the lava pattern, is already fully set up. That means it has the base pattern. It has a normal map, so it has a height map and things like that. So what you can do is you can just take this asset and then just drag it on the floor, and then now everything's lava, which is kind of cool. And then if you drag the offset, you can just sort of move the lava. So this is kind of useful because they already provide these, but we actually want to make our own material here. So we're going to make a second, so inside of that lava folder, we're going to right click and then choose create material, or control click on Mac. And now we'll just call this lava material. And the reason why I do this is because I want to show you how you can do this yourself if you just have your textures. So now we have textures that come from a certain downloaded software, but maybe you have these textures yourself, or maybe you've downloaded somewhere else. A good resource for that, and one that we'll actually use later, is textures.com. They actually have a lot of free textures where you can search for like a concrete, for example. And then they have these nice concrete textures, and some of them are free to download. Or like a low version is free, and then a higher version costs money. But you see that, and this is what I wanted to get at, you see that we don't just have one file, we actually have multiple ones. You see that we have albedo, height, normal, roughness, ambient, occlusion. So what do all of these mean? Well, a material in Unity, whenever you render, is not just a flat surface. Sometimes when you go up to a material, and that's the same thing in real life as well, you go up to a wall, you see that you have all these cracks and little items that sort of reflect the material differently depending on where the light is hitting. And you could actually go inside of your model and actually model every little tiny detail of that surface. So every little crack and notch and every little bump in your otherwise completely flat wall. But you have these tiny little imperfections, and they sort of make everything look not computery. But it means that if you want to do this for your whole object, your object is going to be super complex because you have to have lots of points that are all these things. So that's not really working. So instead, what you do is you add what's called a bump map or a normal map that's actually going to add these little bumps to your surface, and they basically define how the light reflects off your object. So if you have an object and you sort of move around your object, you will see that the light influences that object differently. And that's what these different maps are. So the albedo is like your base color, but then the height map is basically a little bit of detail, extra detail in your map, and same with the normal actually. That's just going to give a little bit of extra texture, a little bit of detail to your little base map so that the light hits off that differently. So that's what's happening here. So with our material, if we made a new material, we see that we have all these properties here. So we have our base material, but then we have all of these other properties. We can choose if it's metallic or not. We can have our normal map, or height map, occlusion map, detail mask, whether the object itself emits light or not, the tiling of the object, and so forth. So let's do that one by one. Let's take our lava material here and drag that onto our shape. You see that we now get our same base color than we had before. This is our default color. If we just want to have flat surface, what we can also do is just hit the color picker here for the albedo. So the albedo is basically the color of the surface if there would be no light, like on a foggy day where everything's like as flat as possible for colors. And so here you can change the color to this like red or blue or whatever, and you see that it has an influence on how the object itself looks. You also see that it's not even everywhere through the space, and that's because the light that we have now, we have one light, which is this directional light that's set up for us by default, is actually going towards a certain direction. So, and then that means that some parts are more light and some parts are more dark. So this material has an effect on the light, or it affects the light, and we can control that effect by dragging these sliders. So for example, we can control the metallicness. You can see that it has an effect on how the object moves, and especially if you move around, you can see that it sort of feels more like a tin can or something, where it sort of looks a bit different. If you don't have it, it's more like a plasticky look. And then the smoothness is basically, okay, does the light hits off very smoothly like this, almost like a glass surface, or is it more like diffused, where the light sort of goes everywhere at the same time? So these values sort of define your base properties of the light. So even with just a color, there's lots of detail that you can already add to that as well. And then where does that source come from? That doesn't really matter if you don't have a setup. If you don't have something set up here, it doesn't really matter. You see that you have these little squares here, and these are actually slots that allow you to insert your textures. So we have these different files, basically images, so the diffuse, emissive, and normal, and we can drag them inside of our lava material. So for diffuse, we can actually drag that into albedo, and that's going to be our base material here. Note that this base material is also affected by the color that we set. So if we set a color here, like the blue, then this is going to be tinted by this blue. So we can make our lava even more lava-ish by changing the color. If we don't want that, we can, as now, we can just set it to white, because in this case it's too much. Another thing that we should note is that the lava texture is stretched across the entire surface of the object, which means that if you go up close, you can see that it's really pixely. And that makes sense, right? Because the texture itself, if you click the texture, you can see it's 1024 by 1024. My screen is actually bigger, so I will see the textures. This gets stretched. A lot of these textures are actually wrapping, which means that they repeat seamlessly. So if we take our lava material, we can see that we have these properties for tiling. So here we can change that to 5 by 5, for example. And now we can see that we see repetitions in our scene, but because this texture is seamless, we don't actually see the repetitions that well. So it's really nicely tiled. If you look close, you can, especially if you look from up, you can see that you have these tiles, right? You see these same patterns repeating over and over. But if you look like this, like normally you would see the camera, it doesn't actually show that much. So the tiling is actually used a lot. And then the offset is what I showed before. It's actually the way that moves the shape. And this can be animated as well, so you can have these lava moving around. We have these other slots here. We have our normal map, so you can drag that in. That's going to immediately affect how the texture looks. So now you can see, if we move around our camera, we can actually see a lot that our shape actually has an effect on the way that the light gets emitted. So it's no longer a flat surface as it was before, but it now really feels like there's some bumps inside of that texture. So this is our normal map. You can also click these little icons here, or click these little dots, sorry, and then you can choose from all of the things that are inside of our imported textures. So if you don't want the normal map anymore, you can click none here at the top, and now you can see that it's flat again. But you can click here and then choose a texture. This is kind of difficult because all of them are here, but you can experiment with different normal maps. Now, this one is set up for this normal map, but you can try out with different ones and see if that looks better or looks more towards what you want. I'm just going to choose the one that I had before. So again, you can drag that in as well. This normal map also has a number, which is the multiplier. So defining how high that normal map actually will affect. So if you think it's too bumpy, you can drag that down a little bit, and it's sort of going to flatten that out until it's 0, which means that it has no effect. Or you can make it even more extreme by going up. At some point, it sort of breaks down because it's no longer working. So you don't have to go too extreme. And then this is lava, so there's also this emissive texture, which in this case, I think with this lighting model doesn't do very much, but we can drag that in here, or sorry, click emission here and drag that in here, and then it's going to add some extra emission, some extra light here. But to actually see that light, I think if you play, we don't actually see much of that light, and that's because we have to do a processing layer with Bloom and things like that to actually see that, and we'll do that later in the course, not right now. So these are the way that you would set up any material. So there's all these properties, and they're really useful to see. You can also immediately see the material here. So right now I've applied the material here, but if you apply it to some smaller object, maybe you don't see it that well, although you could zoom in, of course. So you can also see it here, and you can choose which kind of object that you want to see. So whether that's a cube or like a sphere or a cylinder or a plane. So you can get some preview here, which is very useful. All right. Any questions about materials? No? This is really key, of course, because this really makes your world your world. It really makes the way that things look really your own. So getting a material set up correctly is really important.
Yeah, maybe how you make them, or like, okay, we have the texture site where you can get them for free, but is there a way to make them?
You can make them in Photoshop, of course.
Oh, okay. Also the height and...
Yeah, yeah. So what you would do is you would, this is like almost an effect on the Photoshop layer. So this is, you can do this also in black and white. So now it's in this blue thing, but you can make like a grayscale version of your texture, up the contrast a little bit, and then you have your depth texture or your default depth texture.
Oh, okay, cool.
Yeah. So that's a way that you can make it. But sometimes you also take an existing depth texture and then apply that to a material that you have if you see that it feels correct. Or sometimes people just use brushes to paint it on. So you take an empty texture, and then with a white brush, you take a black square, and then with a white brush paint that on. But you can do that in Photoshop, yeah, for sure. One thing, if you do make your own textures in Photoshop or any kind of application, is to make sure that you make them square like this, and you also use powers of 2. So these are all 1024 by 1024, which is a power of 2, which is a great dimension for the texture. So if you want to make them bigger, you would make them 2048 by 2048. But it makes it more efficient if you use powers of 2, just by the way that the computer works, and it's stored in memory and things like that. So don't do these weird 640 by 432 pixels, because that, like, it makes it, the computer still has to use all the memory to make a bigger texture, but you don't use it. So make sure that you use these square textures. And then also what I do in Photoshop, there's probably some YouTube tutorials on that as well. So if you look for seamless patterns, a way that you would do that by default is to you make a pattern. Oh, this one is beautiful. It has unicorns. You make a pattern and then you offset it. I'm not sure if that's here as well. So you make your default pattern, and then to make it seamless, right? This is what I want to show. You use the offset tool to offset it to the center. So if you have a texture of 1024 by 1024, you offset it by 512, 512, and then everything goes into the middle, and then you paint in the middle. So it feels like it's not at the edge, but you sort of paint in the middle. I'll also link to this video inside of Notion so you can see what I mean. So here I link to textures, and that's the video for textures. Right, and then you get something like this. We can also do the material for these other things here. So I can just use like a dry ground for those, and then just drag that on here. Now here I wouldn't necessarily use the default material, so here I'm also going to make a new material for the planks, and the reason why is because, as you can see, this also repeats by default. So by default we have our dry ground pattern. It tiles 3 by 3, but because this is stretched in one direction, it doesn't actually look that good, because you can see it tiles 3 times this way, but it also tiles 3 times this way, stretching the texture. So in this case, I really have to think about, okay, what's the scale in relation to the other object? So it's 20 by 2, so I probably want to scale it 10 times more in this direction than in the other direction. So I can change the tiling here, and I have to try it because I don't know. So like this, I got lucky this time just by hitting the Y, but so this is in the wrong direction. And this is better, but you can see it doesn't look that good anymore because the texture itself is just too, like it's too repeated, so it's too obvious. But it's kind of, yeah, that's kind of important to get right. Maybe this looks a bit better. And then I can drag that on here, drag that on here. But if they're really different, so if one is really big and the other one is really small, it doesn't really work that way. So you have to make materials separately for this object and this object and this object. So it only works well if they have this sort of the same size. And then for my ball, I'm also going to make a material. So if I don't, so a lot of the materials I now did in the ground and texture spec, but if I want to make my own materials, I can do it here in assets immediately. So I can hit the top level, and now I can make a material, but maybe it makes more sense to first create a folder here called materials. Note that this also, again, makes a folder inside of my scene here. So you see it made this folder, materials. And then inside I could create a new material. So create material, and then call that metallic ball. And I'll make that a light blue-ish color. And then make that metallic. And then now this looks okay. And now I can drag that on, not on the plane here, but on the ball itself. And now if I click the ball and hit F to zoom in, I can see what it looks like. Maybe it's a bit too greenish for my taste. And very metallic. All right. Cool. That looks good. So I have my scene. Let's play to see what it looks like. And you see that one big aspect here of the scene itself that also makes a big difference is the background itself. Wait, first let's check. Okay. Is the background itself. So you see that here the background is gray, but actually if I look at the background in the game itself, you see that it's not gray at all. It's actually this bluish color. So that's because this game is, or the default setting is set up with a skybox. And also, by the way, you can click this game tab to immediately see it. Or what I sometimes like to do is to put them side by side. I'll also show that. So the whole interface of Unity is configurable, which means that I can add extra sides or extra tabs here. So for example, I can take this game tab, I can drag it out and then move it here to the side. And now I can see the scene and the game side by side. So I can see this two side by side. Maybe I make this a bit smaller so it doesn't actually take up the whole space. But it will play in this scene. So maybe I want to hit this little button here called maximize on play. And now if I hit play, I actually get the whole thing full screen. So this is the way that I like to see it, right? So, and then if you don't want that anymore, you can take this game tab and just drag it together with the other tabs, and now it will be united once more with its friends. So you can drag it here again if you want to. And you can also create new tabs. So here on the three buttons, you can say add a tab, for example, game or project or whatever, and then you can add an extra an extra game tab here, so you can have multiple ones if you want. Maybe that doesn't really make sense, but that's up to you to decide. All right, so now, as you can see here, I don't have the skybox, but here I do. So where's the skybox? Well, the skybox is actually part of the camera. So if you click the camera, you can see here that the clear flag is set to skybox. So by default, the camera uses the skybox to clear the scene out. If you set it to solid color, you see this. If you set it to don't clear, actually the scene is sort of doesn't clear, so everything stays here, which is kind of funny because you see the trajectory of the ball. It doesn't work here because the lava is actually drawing here as well. But it works in this wide void because nothing's there. So probably you don't want that here. It sort of makes sense to, if you just wanted black, you'd say solid color and then you move it to black, which can work here in our case, or set it to really dark. I want to show you how to make another skybox as well. So what I'm going to do is set this to skybox, but now I can choose which skybox I want to use. And for that, I'm going to need the lighting tab here. I already have this set up, but I'll close it down because otherwise you don't know where it comes from. So here what I can do in my Unity setting is I go to Window, go to Rendering, and then choose Lighting Settings. And this is really important because it allows you to configure the global lighting of the scene. So where does the light come from? What does it affect? And it opens by default in this window, which I find kind of annoying. So what I can do is I can drag the tab here. So click on the tab and then drag that wherever I want. And I want it here together with the inspector. So I'm going to drag it here. I have navigation here, which I don't use, but now I have lighting here. And here you can see that I have these global settings for the environment. So this is actually influencing which skybox I see. So it's using a skybox, that's for sure, but which one? Well, it's this asset called a default skybox, and we can't actually change this one, or at least I couldn't find a way to change it. So instead, what we're going to do is going to make a new skybox and then apply that as the material. So going here in assets, I'm going to go right click, create skybox, which I have to hunt for a little bit because it's also material. So I click material here and I call that my skybox. It doesn't look like a skybox at all. I can use it as a skybox, as you can see, but it doesn't look like a skybox because it says, well, it doesn't support skybox rendering. So what gives? So I click the skybox here. Now I have to remember I'm in the lighting tab, so I don't see the properties of that thing here. I have to go hit inspector, and now I see the properties of that skybox, between quotes, because it's not really a skybox at the moment. And now, and this is the key here, I change this shader to skybox. So I hit skybox, and now there's a bunch of options. This is if you have images, you can make a real skybox using 6 images, so the cube basically of your sky. But I'm going to choose a procedural skybox, which allows me to set the color of the sun and things like that. So this is my skybox. As you can see, it has this little sun here. It can change the size of the sun, make it bigger or smaller. Change the atmosphere, so you can see it changes the color, which is kind of nice. I sort of like that it's more orangey because it's lava, you know. And then also I can change the exposure, so how light or how dark it's going to be. So make it a bit darker. Tint the sky, so probably this is make it more blue or more red or more whatever you want. Probably want more of this. And then also the ground, make it more dark red. Right? So this is my dark skybox that I want to use. Yeah, it's kind of fun. And then to apply that, so we made our skybox. Note that this is a material with a different shader. We didn't talk about shaders at all, but this is a different way that the material is rendered basically on your computer. So now we can go back to the lighting tab. And in the skybox material, we can pick that skybox. So, and wherever you see this, you can do it always in the same way. So either you take that material and you drag it into that slot like this, or you can hit the little button here, and then you can choose from your assets, you can choose that skybox. So that's the same thing. And of course, this is real time. So you can go back to your inspector, change the colors around, and then see immediately in your scene what the skybox will look like. So this is really a good way to see if the skybox that you made actually makes sense. Yeah. All right. I should probably stop playing with this. Okay. So now we can hit play again to see how that looks. And that looks more skyboxy, or more in line with the colors that I have of my scene. All right, it doesn't look too good yet because we haven't talked about post-processing, but we'll do that later. One more thing, and then we're done with this scene, is that as you can see, it's not actually falling in the lava, but the lava is looks like just a layer together with the other elements. So to do that, what we're going to do here for our lava is we're going to select the lava, make sure that we have our inspector here, change the name from plane to lava, maybe. And then here in the mesh collider, we turn that off because we don't want the ball to collide with the mesh. We just want it to fall through. So now if we play, we see that we roll our ball down, and then what happens is that our ball actually goes through the material. So it doesn't actually hit the material. What we can also do is we can have a trigger event. At the moment it hits it, it just disappears, but now it just falls through, so it just keeps falling because this is the ground, we don't actually see that. Another thing that we could do with the lava, but I'm not going to do that here, is we can add particles, so we can have lava actually, or little bubbles of the lava spewing out, which would be cool, but we're not going to do that. So if you want to look at that, there's particle systems, and those are actually little balls or things that actually emit from that object and then move here. As you see, they're kind of not the right color right now because they don't have any materials, so the material is just nothing in this case. So you want to use transparent materials and things like that. But these are actually really useful because there's so much options that you can set of where the particles come out of the shape and how they move and things like that. So they add a little bit of dynamic things to your scene. But I'm not going to talk too much about particle systems right now. So I'm going to remove that component from the lava. All right, any questions? No?
No.
All right. So what I'm going to do now is we're going to do a little break, get some coffee, and then also I'm going to, after the break, we're going to start with a new scene where we're actually going to take in existing assets and then build a scene out of, build a little city out of those assets, and then walk around our little city. All right? Cool. So see you in 10 minutes, so 11:20. See you then.
Okay, sounds good.
Okay.
Zoom recording. So we made, in Unity, we made this lava scene. There are a couple of other extra things that we can add to it. Maybe one thing that I want to show, because I sort of did it last time and it's actually useful, is to add a light to the sphere itself. So now everything's sort of a little bland, a little boring. But one thing that I found was really funny is you can add lights inside of the scene, and we'll do that more in the next scene. But for example, if we click the sphere itself and we add a light, a point light, now the sphere emits light. So especially if we increase the intensity, so we can drag that up, you can see that the sphere itself emits light. And so you have to work with both the intensity and the range. The range is how far the light goes, and the intensities yes, the size of the light. So these two work side by side. So now if we play the game, we actually will see that the light has some, I don't think you see it in the top one, but it has some effect on the bottom part. So this is kind of funny. So that objects themselves can have real-time lights, and this actually makes the scene much more interesting already, especially if you darken everything down. And we'll go more into that, but in lighting, for example, there's a lot of options. You can say how much does the environment influence the rest of the light. So here, that can be changed to actually darken the whole scene, although I don't actually see much. of that going on. And then especially in the directional light, which is a default light, if we change, where is it? So we hit F here. Moving the directional light doesn't really matter because the directional light is only the direction matters. It's sort of like the sun, but you can rotate that around. So if you hit E and then you rotate now, you see that it has an effect on where the direction is actually coming from the light. And of course that has an intensity as well. So lowering that down, especially like this, and then if you play it now, you see that the light of the ball actually has much more effect because the directional light is now off. So these are small things, but they all already make your scene a bit more interesting. And this is why the parent-child relationship is so useful, because the light is now part of the sphere. All right. But we're going to make a new one, and specifically we're going to build a little city here. So we're going to do File, New Scene. And note that we're still in the same project. So this next scene is also in the same project, which means all our assets from the project are also there. The first thing that I do when I make a new scene is I save it, because it doesn't know where the scene is. So I'm going to put that in the scenes folder. I already have that sample scene. That's the lava scene that I just made. So now I'm going to make my city scene and save that there. Again, in your project browser here at the bottom, you can look at scenes and you can see that that scene is here. So those are the two scenes that I have now. And this is empty. There's nothing there. So what I want to do is I want to import assets, but the assets are not inside of the assets store. They're actually from a different site. So first I'm going to download them. So I'm going to open Chrome, take a new tab, and then go to Kenny with an EY at the end. And these are free game assets, 3D assets. They're really fun to play around with and build things with. They're free for commercial use, so that's why they're used a lot. And now I can go to download assets or click assets here. Now I can see all of the assets. There are some packs that you can buy that have much more assets than the default ones that I'm using here, but I'm looking for a specific one in the category 3D. So I click 3D here, and then I'm going to go to the next page, and the one I'm looking for is this one called modular buildings. You can also just look for Kenny modular buildings, and you'll find it as well. So this is about 100 assets that all are parts of buildings that you can combine into the larger buildings, which is what we are looking for here to make our little city. So we can click download. It's not asking anything. You can donate if you want, but they're free to use everywhere. And this is a zip file, and we'll go look in that. So I do show in folder. This is the zip file that I have. I open it up, and now I see that I have all of these things. I have the preview, I have a sample, I have the Unity package. So what I'm going to do is I'm going to unzip this. So I have 7-zip extract here. On Mac, you can just double click, and it's going to open that in a folder, which is this one. And you see that you have your unique models here. On Mac, you can look at these OBJ files by clicking one and hitting a spacebar. On Windows, I think you can just double click. And you can see this is like the most boring one. But you have these parts of the building, right? This is like a roof part and things like that. They're just numbered, they don't have any names, so they're kind of hard to figure out what they are. You also see that they're flashing. This is a bit of a problem that will come up later. They have some textures here, but they're not set up correctly. So they're this is a bit of an annoying thing. That's what you get with your free assets. So whenever you are doing lighting, this will wreak havoc. This will become a problem. So especially when baked lighting, this won't work. So it's good to know that we are going to run into issues later. In Unity by itself, it's not really a big issue, but here, as you can see in the preview already, it started flashing, and it's sort of an indication that something's wrong with the way that the asset is set up. It's kind of unique for this one to actually not work, because most of the ones from Kenny are actually set up correctly, so it's kind of annoying that this is not doing its thing, but whatever. And then this conveniently also has a Unity package, which is the one that we want to use. So we're going to go back to Unity in our empty scene here. And now here in assets, we're going to go to the menu assets, import package, and then choose custom package. And now we're going to hunt for that package. So I had it in downloads, Kenny, Unity package, and then this is the one that I'm looking for. So I click open, let it do its thing, and now I can choose which assets that I want to import. So here I just want to import everything, so I click import. And as before, we get another assets folder called modular buildings that will be added to our assets folder here. So we had our ground textures, and now we have also the modular buildings. And note that we always have two files here. That's just the way that this one is set up. We have our building itself, and then we have the material file. This one is not actually that useful for us. What is important here is that all of the materials actually have a default size, and it's a bit too small. So remember when I said is that we should look at our scene as one unit is being 1 meter. These assets are actually set to 1 meter as well, which means that our buildings are just 1 meter big, and they're just made for tiny people. So we actually want our buildings to be a bit bigger. What I found is that if I make these buildings about 5 by 5, they sort of make sense. So a building from side to side is about 5 meters in general. I'm just over generalizing a little bit, but that's like a useful unit to have. So instead of using a scale factor of 1, I want a scale factor of 5. So I'm going to select go to favorites, all models. So that's going to select all the models that I have imported here. And then now do select all. So Control A, or right click and do select all. I think I can do it here as well. Not really sure. No, just do edit, select all like this. And then here in the scale factor, I can set this to 5. And now everything will be scaled up a little bit. And now it says, would you want to apply? Yes, apply. And now it's going to scale all of these assets. Oh, I should have hit the apply button here. This is the one that I was actually looking for. So 5, and then hit the apply button here. And then there's all these other settings that I'm not really interested in right now. Now, when I start dragging a building inside of my scene, first you'll see that it's quite big, which is kind of the point. But also, and this is a kind of a problem, it's sort of putting it somewhere in the scene. As you see, it's not really putting it on the ground at all, because it doesn't know where the ground is. So to solve that, the first thing that we need to do is just delete that asset out, and then make a new game object, a 3D plane. So basically we want to make the ground first. So we create our plane here, set the scale to 20 by 20 by 20, so we have a bigger space to work with. And then also, because I constantly hit this plane when I'm selecting things, I want to make sure that I can't really select this plane anymore. So what I'm going to do here is, in my hierarchy, I'm going to hover over my plane, and you see I have these two icons here. One is to hide the object, and the other one is to stop the object from being pickable. So I can't select it anymore. So if I click here, now if I click, I can't actually select it here. I can still select it here, but I can't select it in the scene anymore, which makes it useful, because now if I click something or if I drag something, I always hit the right element instead of just hitting some random stuff. All right, and then I'm also going to drag a building on now. So I'm going to look for a building that has a door, like this, for example. And now I can drag that on. And now it should actually be on the floor, as you can see here. So this is actually the right position. So the Y value is now at 3, which is fine, I think. It's still sort of floating in the air, apparently. No, let's do that again. So I'm going to set my position. That's because it's set on the plane, but the plane itself is at the position of 3. So I want to have the plane at 0. Much better. And now I want the building also to have a Y value of 0. So now it's flat on the ground here. Cool. You see that the X and the Y values are kind of these weird values. Now, because these are modular buildings, as you can see, they're sort of nicely aligned to the grid, or they should align nicely to the grid, but because we have these uneven values here, it doesn't really work. If I have these buildings constructed as modular buildings, I probably want them to be like on fixed positions. And I can do that by using my snapping tool. So here I can toggle snapping on. Why don't I see the snapping? Oh, now I can do it. So I click the scene first. I click snapping, so you see it's selected here. And then this one is set to global, so you can see you can change. And then here, this one, you can choose between center and pivot. Because the buildings are 2.5 by 2.5, we actually have to set it by pivot. And now if we drag the building, we see that it nicely snaps to the correct squares of the grid, right? So you see that it snaps here in the corner and it snaps here in the corner, which is exactly what you want. So this is very convenient. If your buildings are set up correctly, you can see that it nicely snaps everywhere the position is correct. So that works really well. All right, so now we can add a top building or another floor on top of that. So I'm going to take this one, drag that on, and yeah, so it's also attached or sticking to the floor, but we actually want it to be like here on top of the other building, right? And there are a couple of ways to do that. So we can drag this thing here, and we can drag the blue one, and then sort of hunt for the correct one, and then sort of try to see if we match that. And that works. There's actually an easier way, so I'm going to undo this. And that's using this technique called vertex snapping. So a vertex is basically all of these points of the element itself. So we don't actually see them, but this element, it's kind of obvious, has these blocky little shapes. And so this point here at the corner and this point at the corner and all of these points, also of the window, are all vertexes, basically points of the object. And so with vertex snapping, what we can do is we can take a point here, for example, take this corner point here at the bottom, and snap that to this corner point here at the top of this building. So it's basically this building, the bottom of this building snaps to the top of this building. And to do that, we are going to go to our move tool and then hit the V key, hold the V for vertex snapping. And then you see that as I move over my shape, it's going to highlight the vertices that I can snap on. So I'm going to hit that corner here, now drag, and now go to that top corner here, and now they are snapped perfectly into place. So you see they fit nicely here. And this is really important because for the X and Y values, it sort of makes sense. You see 0 and 5, that's kind of normal. But the height of these modular buildings is actually set to this weird value. So doing that with just snapping like this doesn't actually give you the right value. So there it's better to actually use vertex snapping to move that on top. All right, let's add another floor. So let's take this floor here. Again, use the V key to snap that on, move that here, and then we snap that nicely to the building as well. And then finally, we'll make a roof for this little building. So there are a couple of roofs inside of here. I like this one. And here I sort of have to pay attention because here if I do vertex snapping like I did before with the V key and then hitting this one, it's not actually, it's snapping, but it's not actually correct because you see that the roof actually extends a little bit beyond the shape itself, right? So it's snapped perfectly on this little corner here, but that's not actually what we want. There is some overhang of this roof building, which we don't want to snap here. So a better strategy is to vertex snap to the back side of the building. So here, again, I can move this up a little bit, take the back side, use vertex snapping, so hold the V key, and then drag that to this corner here. And now as you can see, I have this nice overhang here with the building, no problem, and I have the back side nicely aligned here. Because of directional lighting, I can't actually see the backside really well of the building. I can change that. I can take this directional light, go to rotate, and then rotate that light around so I can actually see the back. But if you want to temporarily look at the backside of that building, what you can also do here in the scene is hit the little light icon, and that's just going to turn off all lights and just have a really basic lighting setup. So now you can much better see if everything's lighted correct or moved correctly. So I often switch between those as well to get the real-time lighting or the like the default lighting. All right, are you with me so far?
Mm-hmm.
Rijke?
Yeah, I'm good.
Yeah, I always forget my mic is not on, so I answered, but yeah.
Cool. Cool, so we made a building. That's awesome. And now is the time where we actually want to, well, we could make another building and another building and another building, but if we were trying to make a city, a lot of that we probably want to repeat, just to make it easier for ourselves, right? So we have made this building here. We basically would want this building to also appear sort of as a model here, so we can just drag in a building of this kind, and we can make a couple more, but it would make sense to have this default building here. And to do that, what we're going to do is group all of these objects that we see here. So we have all of these objects here. And then group that into a new one, and then make that into what's called a prefab. So make that into its own building that we can just drag in as an instance. You know that these are actually blue, and they have a little bit of different icon. That's because these are actually prefabs. These are actually buildings that we dragged out, as I saw before. So you can make prefabs of prefabs. So let's do that. Let's go here in the hierarchy, and to make a prefab, what we do is we create an empty object first. So this is our empty object, and now we can give our empty object a name. So I'm going to go here and rename that to house. Let's call it house A, because we might have like a house B. So A is my letter of my variant. For example, I have an A house, B house, or whatever. You can also number them if you want. And then you can take all of these, which are all the parts of the building, and drag them below house A. So now if we drag house A, you can see that everything moves here as well. I'm not too happy with the location of these parameters. So what I'm going to do is I'm going to actually do it again, just to make sure that everything works. So here for house A, the problem is that, and you can see it here, that the little gizmo, the little location of the center point, is actually not on the ground floor. And I really want this thing to be here. So if I drag a new shape, that it's not like in the center of the plane, it's like stuck halfway through the floor. And to do that, what I need to do here is I need to reset my position. So I'm going to select reset here. And I'll take all of these parts of the building and then drag those in house A. And now if I click it here, we see that the corner, this little corner is now actually the part of the house that I can drag, which is much more convenient. Especially because I can now, if this is set to Y0, then this actually means that the building is on the ground, right? Especially if you start making hills or whatever, it's really important that you know how high your building is going to be. All right.
And
so
how to do that, the gizmo thing.
I did it again. So let's go over. So I have these buildings, right?
Yeah.
I'm going to create an empty here.
Mm-hmm.
Rename that house A. And now you see by default, because whenever I make a thing, it's just in the center of my view. Now here I'm going to reset my view position here.
Okay.
And now I want my building to actually be on that corner. So if it's not on that corner, what I can do is I can take all of these elements and just drag them to the location of where the gizmo is.
Okay, yeah.
And then once it's correct, then we sort of drag that in. So you have to be a bit specific where you want the location of your building to be. You can change it later, so you can select these objects and sort of drag these inside of your element as well. That works, but it's sort of confusing. So what would have happened before, if I didn't do it this way, it's kind of good that we take some time to work with that, because it's kind of confusing if you don't see it. So imagine that I have this game object that's in this random position. I don't really pay attention to it. I do house A. I take all of my buildings and drag them in.
Mm-hmm.
Now you see that if I have this building here, and now if I quickly make a prefab by dragging it in, I drag it here, you see that a new building now goes here, right? Because the center of my building, or this gizmo, is set up to the plane, to the center of the screen here. So this is actually not what we want. But because it's already here, we're sort of, we sort of have a problem. So to fix that, what we can also do is we can reset our transformation on the main element, and now select all of our buildings and drag them up to the position that we want. It's more confusing or more annoying because, yeah, it doesn't really snap that well, as you can see here. We sort of have to mess a little bit with it to make sure that it snaps. But we can fix it later as well, as you can see. But it's much better to do it before.
Yeah, okay.
Right, and then you already saw me do something with a prefab, and I'll do it again. So I'll just undo the whole thing. Yeah, if I select these buildings here and I have the house, what I can now do is I can make that into a prefab. So I'm going to make a new folder here, create folder prefabs. These are all the pre-made things that I'm going to do. So I'll take my house here, I'm going to drag my house in, and now that house becomes a prefab. So now it's one building by itself, one unique block, which is super fun because now I can take this block and drag it in here, and I can immediately make a new one. So I can attach them side by side and drag another one here, like this. Yeah, just copy and paste. As you can see, these are all blue, which means that they're all prefabs. So I can copy, paste, make another one here, copy, paste. And now I have a whole street of them. And now I can maybe move these here, take my street, and now duplicate them as well, drag them to the other side, and now rotate them in Y 180 degrees. And now they're like, I have a street where I have buildings on both sides of the street. Which is super fun. As you can see with the light, currently we don't actually see the buildings that well. So we probably have to play around with the light.
Oh, Frederick, how did you make a prefab, just real quick? Because I can't find like a create prefab or whatever.
No, it's actually much easier. You just take whatever you made and you drag it in here. You drag it into Brigade. And then that becomes a prefab. And then you see that the thing that you just made now becomes blue. So it's already the one house that you had is now already a prefab of that building.
I mean, sorry, because you made the first step of making house A, like it's a prefab object or something, right?
Yeah.
How were you able to
I'll make another one.
do that?
So see.
Okay. Sure.
So I'll make another modular building, and then hopefully that clears things up. So go to all models. And then maybe this time I want one that looks like this. Again, I can align it to the grid, make sure that that's correct here. Check that the Y value is actually correct. Maybe set the X to 0. Add a second floor, like this one. I'm going to zoom in with F. Use vertex snapping to actually snap that here. I'm going to turn the lights off here because it's very difficult to see. And then make two windows at the top here. Oh, and then add a roof. Again, with the roof, make sure that you take the back side to snap it because it doesn't work with the front. All right, so now we have our second house. And now what I'm going to do to make the prefab is create an empty, call that house B. And then here, note that I have to reset my transform, but that's going to reset my transform to here. Now my building is here, so actually I'm going to move my transform all the way here, which is a much better location. So the Z-axis is now at -30. And I'm going to take all of the parts of that building, drag them below to house B. And now this is just a house, right? So it's, you see this one is white, so it's not a prefab yet. Now I have created this folder in my assets called prefabs, just by create folder. And now to make a prefab out of this, what I do is I just take this house and I drag it in. And note that the moment I release, I have this house here, and also the color of this one changes.
Oh, okay. So you just have to drag it. That was the part I was missing.
You just have to drag it in. And now you see that the house itself has changed, right? Before we had other properties, but now here it says prefab, open, select. So I can select this prefab here and I can look at it. And also and this is kind of convenient. I can also open the prefab by double clicking here or doing open prefab. And now I'm in what's called prefab mode. So now I don't see the rest of the world. I just see the house, that single house. And I can start changing parts of that house if I want. And those will have an effect on the whole world. So for example, I take house A, so this one here, I double click, and maybe I don't like one of the parts of the building here. Maybe this part needs to be something else, or I think it should be something else, or this one. So I can delete this, maybe drag in this part, use vertex snapping again to move that into place. So now I have this one with the different windows. I go back, and now it says, do you want to save? Yeah, sure. And now you see that all of them have this new window, right? Because those are prefabs, right? So they're all now influenced by this new thing that I made. Maybe a bit more light here. Does this make sense?
Yeah, so it's like editing a master page in like InDesign or something.
Yes, yes, indeed. That's a good analogy. Yeah. All right. So we have our little street here. Because we have two prefabs now, we can sort of mix it up. We can have a couple of those here. Maybe we want to have a little nook here, a little side street. We'll duplicate with Control D. Make some more here. Maybe select those four, duplicate them, move them to the other side, like this, and then rotate with E. If you want to rotate on a specific angle, what you can do is hold Control key, and that's going to rotate in increments, so you can snap them to a certain value. Most of the time, what I do actually is just type in a value here because it's much more useful. And I move them correctly into place. So, and this is how you make your city, right? So you just do this over and over and over again, and then you have your little city. So what I'm going to let you do as an exercise is just make an apartment building, and then you can show it to me. So you can use these models here. There are some for apartment buildings, like these ones. So you can use that to make a bigger, like a high rise, like a 5, 6 floor, 10 floor high apartment building. And then you can also use this as a roof for the apartment building. And if you want to be real fancy, you can also add an air conditioner at the top. So go for it. I also do that, but just don't follow me. Just try doing that with the tricks that I showed with vertex snapping, and then also make that into a prefab and have multiple buildings there. Maybe put them here at the end or something. right, so something that, once you have something that looks like a building, you can also do this prefab step or dance again. So I'm going to call this office A. Reset the position. Go look for my cursor. I just want to move that all the way here to the corner of that office building. And then just select everything from that office building. So I have a couple of them here and a couple of them here down there. I'm not sure why. I'm just going to make everything here. Make sure that I have my air conditioning selected here. All my parts of the building. And then drag that into the office A's. Done. Now if I drag this whole thing around, yeah, I have the whole building here. And now I can go to prefabs, drag that in, and then that's my office building. And then now I can drag more office buildings there. Of course here, especially with the modular thing, it really makes sense to have a couple of variations that you can sprinkle around your city. Otherwise, everything will look just exactly the same. So try to do at least 2 of them if you want to make some variation, because otherwise everything will just look the same. Especially here with the houses as well. It sort of makes sense to, yeah, have maybe a couple of those actually of this type inside, because yeah, otherwise it's just a bit boring. All right. Any questions?
No.
It's fun, huh? I think this is fun. This is really like world building. So now it's really up to you to decide what your city is going to look like. Already with the camera, we can sort of move it around by just dragging, and we can look at our preview to see like, oh, we can hit snapping off. You can sort of feel how the city feels if we drag it around. That looks cool. You can sort of see that it sort of fits the 5 meters that we selected, so the size is kind of okay. We can enter a building at least. But it would be fun if we could actually move our player around. So how do we do that? Well, this is the part where I think Unity sort of dropped the ball a little bit, because there's no default component or something that you can just drag on and then it moves. You really have to do some coding for that. And I don't mind, but it's kind of weird. I was really looking for this inside of the application and it's not there. And I think it's because every game does movement a bit differently. So we have to build our own movement ourselves. We're first going to reorganize our scene a little bit just to clean it up. So we're going to make a new empty here. We're going to reset the position of that, and we'll call this one houses, or environment is maybe a better name. So that's just everything. And then we take all of our office buildings that we have here, and we drag them inside of our environment. So just to clean things up. And then we have our basic plane here, which is just the ground. That's also part of our environment. So now we just have the main camera, the directional light, and then everything of the buildings. This is not really necessary, but it's just nice if you're working with this just to clean things up. If I would do multiple streets, I might also inside of environment do like street 1, street 2, or give them funny names or something. So, all right, so now we cleaned it up. How do we make our player here? How do we actually move our camera? Well, then we have to think a little bit about the input system of Unity. So the way that, if you want to have control, the way that you think about it is to have control is to actually make sure that you can do some input. You can give input to the system to actually be able to control that. And so the input, the way that you work with this is to connect input to movement, to either rotating the camera around, or to move the position, so move transform the position here of that player around. That's really what we want to do. So on one side, we want to be able to rotate our camera like this, well, not like this, but like this, for example, if we move our mouse, like a typical game, and move like this. And then on the other hand, we also want to be able to move our player in the X and Z locations, so we can actually move our player like this. All right, so first we're going to make something that resembles a player. So we're going to do create empty, and we're going to rename that to player. So that's our player. It doesn't have any shape, it's just this empty object that we have here. So probably it makes sense to attach a shape to it so we can actually see our player, even though our camera won't see it because it will be invisible, but it's something for us so we can actually see where our player character is. And because it's not visible ever to the game itself, it's just for us, we can do something really, really basic. We can just make a 3D object like a cylinder, and that's going to be our player. So I'm going to use F to zoom in. You see our player is now outside of the world. It's not very useful. So I'm going to reset the position of our player, use F to find him. And then what I'm going to do is I'm going to take my cylinder and move it up. So not the player, so the player can be at 0, 0, 0, but the cylinder, actually I want to move up. And I can use snapping here to put it in place like this. It should be at a position of 0, 1, 0, and then a scale of 1, 1, 1. So the 1, 1, 1 is basically cylinder of 2 meters high, which is sort of like a normal height, maybe a bit large, but whatever. And now we can move our player here in the X and Z directions by just dragging here, so we can move him somewhere inside of the street like this. So he's in the middle of the street. And then, like we did before, we want to take our camera and actually attach that to the player. So we're going to take our main camera here and drag that inside of our player. And then for the main camera, we're also going to reset our position. Because remember, the resetting, so the transform now is like a local transform. So this transform is now in relationship to the player. But because Unity just takes whatever values it had before, it's going to move that camera here. So we have to reset this one. So now the player, and we can hit F to see it again. Now the camera is actually inside of that cylinder. So it's kind of weird to have your eyes at your feet. So what we're going to do is we're going to drag that up. So our position is actually, well, maybe not at 2, maybe it's a little bit inside. So like 1.7 if you're like 1.7 meters, or 1.8 or whatever. So this is the height of what you can view. So this is basically your eyes. Note that we don't actually see the cylinder. This has to do with the fact that Unity doesn't render the inside of objects. So it's actually fine that the cylinder is here because the camera is completely inside of it. If the camera was behind, we would actually see the cylinder, but once it's inside, we don't actually see it. So now if we move the player, we are actually moving our camera, right? Make sense? No? So, and now it's time to do the actual scripting. So now we have to do a player, and we'll do 2 scripts. One is for moving the camera based on the position of the mouse, so basically looking up and down and left and right, but not moving. And the other one is for when we hit keys on the keyboard, like the arrow keys or the WASD keys, like you do in games, to move the player actually. So we look in a certain direction and then we move forward in that direction. So first, eye movement. So first we want to look around our scene without actually being able to move around, so we're paralyzed a little bit. And to do that, we're going to select our main camera. So this script is going to be attached to our camera. So we'll select our main camera and we do add component here. And as I said before, there's no built-in component, so we have to write it ourselves. So we go here at the very end and we select new script, and then we can give it a name. So I'm going to give this a name, player look. Note that the way that I type this, so I don't use any spaces. They're a bit evil inside of scripts, so try to avoid using spaces wherever you can. And because it's 2 words, I actually use this uppercase in the middle. This is called camel case because you have these humps in the middle of your word. And then you select create and add, or just press enter. And that's going to attach a script to our player here. Now, the script doesn't do anything because it's empty. Unity has created the script, but we don't actually see what it's doing. So now we can edit the script by going here in the 3 dots and selecting edit script. And now something might happen that might be different from your case. In my case, it's going to open up Visual Studio Code. In your case, it might open up Visual Studio, or it might ask you which program to open. I'm just going to work with Visual Studio Code, but please tell me what is happening on your computer. I think by default it will open Visual Studio.
Yeah, for me it did, but you can also put it as your main editor or something. Well, script maker somewhere in the program.
Yeah.
I don't remember.
Indeed. So you can select another editor. Remember, again, you're working with a file system, so we already know a little bit of Visual Studio Code. So what we can also do, well, I'm using Visual Studio Code, but if you're using something else, it doesn't really matter. But here I can do File, Open Folder, and now I can just select the whole Code Studio project, select that folder, and now I just look at it as a folder. So now that script that I wrote is in the folder Assets here, Player Look. So this is exactly the same thing. So I can just look at that script, and the moment I change this and I go back to Unity, Unity picks up that change and it will actually recompile that script or rerun that script for me. All right, so let's talk about scripting. This is in a language called C#, which is sort of similar to Java, which is sort of similar to JavaScript if you nudge a little bit. And Unity has a very specific way of doing that. So it's called this mono behavior. So this is a default script, always are these behavior scripts. And they have two parts, and they're sort of self-explanatory. Start is called before the first frame update. So if you want to do something in your script, when the game is started, you can do it here. You load in a resource or whatever, show something on the console. We can actually do this already. So we're going to type print like this with the brackets, and then with double brackets type hello from the player look script. And then, and this is different from JavaScript, we have to write a semicolon at the end. Then we do save. And now if all goes well, we go back to Unity. And now we hit play. It should say at the bottom here, it should say hello from the player look script. We can also see that here in the console. So this second tab here, it also says hello from the player look script in a Unity Engine mono behavior print object. So this is the, if I click this here, you can actually see it's done in player look start at assets player look CS10. So this is where the data comes from. Does this work for everybody?
Yes, for me.
Yeah.
How did you edit the script? Sorry, I was looking at my Unity.
You can double click here, the script, or you can go to your project and then find the script here and then double click it here. Or you can do show in Explorer and then here do open with. And I have Visual Studio Code selected by default, so I do open with code and then it's going to open in Visual Studio Code. By default, I think Unity also installs Visual Studio, which is probably a good idea because Visual Studio Code doesn't do auto-completion, so it doesn't actually tell you which commands are there. You have to look at the manual constantly. Whereas if you use Visual Studio on Mac or on Windows, then it does auto-completion.
Okay, thank you.
So, but we're going to type everything from scratch, so it'll be fine. So, as I said before, I have this script set up in Notion at player movement, so you can actually see what we're building here. The trick is that we are going to get the value of the position of the mouse, both in the X and Y direction, and we're going to use those to rotate our view. So this is actually based on this video, which I also linked, first-person movement in Unity. It's a really good video that explained it a lot. So let's think about it. So if we have our view here, if we move our mouse up and down like this, so if we move our mouse in the Y direction, what needs to happen is that we have to rotate along this red axis. So this axis, which is the X axis. So moving the mouse up and down actually rotates in the X axis. So not in the Y axis, but in the X axis. Same thing, moving the mouse left and right actually means that we move our mouse here in the y-axis, right? So it's kind of flipped from what we normally would think that would happen. So it's important to keep in mind. So first question is, okay, how do we get the movement data out of there? So how do we move our mouse left and right and up and down? And again, I'm going to cheat a little bit by looking at the code that I already wrote, because I can't really do it from scratch. So I'm going to say, well, take the mouse X position, or the mouse X position is the input. So this is how we get the input. And now we ask for the axis called mouse X. So this is how we get that mouse X data. And that's going to give us a value of the mouse X value. I think we can also print that out like this. Now, if we play our game, I'm also going to turn off maximize on play so I can actually see the console here. We can see that I have a value here for the mouse going from 0 in the middle to I think 0.5 or something, like this. So this is my movement in the X direction, X rotation. And then I have the same one for the Y value. So I'm just going to copy that line, paste it here, and say mouse Y. All right, and then what I'm going to need to do is, and you can sort of tell by the script here, if you run it, is that if I don't move the mouse, it's going to be 0. If I start moving the mouse, I have some values, and then it goes back to 0. So it's not actually the position of the mouse on screen, it's more the movement of the mouse. So while I'm moving the mouse, it's giving me these values. But the moment I stop, I don't see them. Now, that's not really what I want here, because I just want to, if I move my mouse to the left, I want to look at the left. If I want to move my mouse to the right, I want to look at the right. So I have to sort of remember that movement that I have and sort of add that movement to the existing movement. So I'm going to store that movement, that rotation. I'm going to store that in a variable. So here at the top, I'm going to make a new variable called x rotation equals 0f. And this basically means a value of 0 as a floating point value, so a number with decimal points at the end. And here what I'm going to do is say, well, the x rotation, we're going to add our mouse y to it. Remember, mouse y, the position of the mouse y is actually moving this x rotation here, so it's moving this angle, right? It kind of feels like the other way around, but that's how we should do it. And then for the y position, so meaning the angle like this, sorry, the x position in the x-axis, but the y rotation, we're going to actually just do rotate. So the way that we do this is we're going to have a reference to the player itself, because it's not the camera that we're rotating, it's the player that we're rotating. So we're going to reference our player, and then we're going to rotate that player object. So that's a lot. So let's figure out what we have to do. First, we have to know where our player is, right? If we want to rotate our player, so like this, then we have to know, our camera has to know where our player is. So we have to have a reference to that. And the way that we do that in Unity is we can just reference this by using public transform player. Let's call it player body, or just player. And now, because note that it says public here, if we go to our camera and we let it compile and we look at our script, we see that we now have this player thing here. So this is a property, just like these other properties. This is now a property that we can set. So now Unity is asking, okay, where, so you link to a player, but where is that player? I can't find it, it's nowhere. So now we can take our player object and we can drag that in here, in that slot. And now the camera knows where the player is. So now if it can rotate that player around. So that's what we need to do. So again, we do this public transform player to make sure that we can access it. And then in Unity, we can set that value here. And then let's actually rotate that. So we're going to say, and this will fail in the beginning in funny ways, but we'll let it do its thing so you can actually see what's going on here. So I'm going to say player dot rotate, and I'm going to use the x-axis. Remember, that's this axis to rotate the mouse X using the what's called the up vector. This is kind of something that I maybe don't want to explain too much, but the whole way that we look at space in 3D is by using vectors, so basically positions in 3D. So we have to rotate based on what the system knows is up. All right, let's see what that does. As I said before, this will fail in funny ways, which you'll see here. So this sort of looks okay. The Y doesn't really do anything, but we can sort of move around in one axis already, which is kind of good. Does this work for everybody?
I haven't written all of the code yet, so I'm still
okay. I'll just wait. Yeah. Remember, if you're completely stuck, all of the code is it's available on Notion, so you can copy that first script, and it's exactly the same as we're writing here.
This is very similar to C++. Well, it is also C, so, but I don't know how different it is.
C# is, it's very similar. It's really got its idea there. Yeah. Is it working for you, Lucas?
Hold on, I think just leave the the code open, because maybe I missed something or a variable is incorrectly input by me.
I should probably show you what happens if I make a mistake. So imagine that I forget a semicolon, for example, here, and I save. If I now go back to Unity, I get this error here. So you see that at the bottom, everywhere in your project, so even if you're here, but whenever you're coding, it makes sense to have this console open, because there it says asset player look, CS, line 24, position 43, error, semicolon expected. So line 24 is this line, and you see I miss a semicolon here, so it's actually pinpointing me in the right direction. And now if I save and refresh, the error is actually gone. So if you get errors, make sure that you check the console to see what's going on. Marijke? I say submute. Yeah.
Like my, let me check. The variable player of player look has not been assigned yet. So there's something wrong.
Yeah.
With...
So here in your
the same error.
Okay, so here in your camera object, you have this player look component script, right? This is the thing that we added. This is the script that's the player look script. Here it says player. This one actually needs a reference to the player. So here, this one is probably set to none in your case. At the bottom here, do you see where I'm pointing at?
Wait. Yes, indeed.
Yeah. And so what you do is you take your player object here and you drag it inside. So now the camera knows which object to influence, because it's rotating the whole player. It's not just rotating the camera, it's rotating the player itself. So by dragging that in, we actually make that rotate.
Okay, yeah.
And now if you play, you should be able to move side to side by moving your camera like this, but not up and down yet.
It's doing it.
Cool. All right, so let's do the up and down movement. This one is kind of weirder, but that's fine. So we're going to write transform. So the up and down movement is going to be influenced so that's going to be on the camera, whereas the player movement, so the left to right, is going to move the player. There's a good reason for that, and that's because in a moment when we move forward, we want to make sure that we move forward in the direction of the player, right? So if we are moving forward, we actually want to move, if our cameras, or if we are rotated in this direction, we actually want to move in that direction, right? But the same thing doesn't happen with our rotation. So if we are rotated like this, we don't want to move like this, right? It doesn't, like, we don't work that way, right? There's gravity and kind of annoying, but so that's why the movement is actually inside of the, let's say, the eyes. And so the up and down is actually inside of this movement, but rotation actually comes from the player itself. So it's kind of good to know that this actually needs to happen here, because if we move, we actually want to move this way. Does that make sense? It sort of intuitively makes sense. Let's forget about the code, but it sort of intuitively makes sense. So the rotation, left to right moves the player, but up and down, so going up and down, moves the local rotation. So moves the rotation of the camera. So we say local rotation equals, and this is annoying because now we have to write quaternion dot Euler x rotation 0f 0f. What? So Unity has a very different way of expressing rotations, which are called quaternions. We're not going to go into detail. It's way beyond scope. But basically here we specify the rotation in x, y, and z. And so here we are just concerned with the x rotation. So that's what we're setting here. So now if we save with this code and now we go back, let's check if it works. Now we can actually move up and down and side to side. I'll let you type this, especially the spelling of quaternion.
We should complain on the Unity subreddit to just have them have baked-in camera controls.
That they don't have that.
Yeah, I'm surprised. Like,
yeah,
there have been several like first-person shooters that have been made with this, but
yeah, it's so weird. You can buy them, but it's like, why is this not built in? Like, I think it's kind of a good thing to get into scripting, like you have to, but yeah, it's maybe not the easiest scripting to start if you have to write quaternion in your first script, but whatever. One thing that's wrong for me, at least, is that if I play this and I move up, the camera actually moves down. I'm not sure if you see the same thing. So it moves in what I feel is the wrong direction. To flip that direction around, what I can do here is, instead of writing x rotation plus equals, I can write minus equals. So now the rotation is subtracted from the original one. And now if I play, now if I move up with my mouse, I actually see up. If I move down, I see down. And now you can see the whole scene. Does this work? Marijke, Lucas?
Yes.
All right, you made a camera movement. That's awesome.
oh yeah, I had an error. I changed so I put transform and did tab so it would autocomplete, but the transform became a capital T. So
Yeah.
And I changed it to a lowercase, so then it solved the issue. So that was weird.
Indeed, there's a difference. So transform is actually referring to this transform, or specifically this transform of the camera. So you can see it here as well, actually. So if I now move, we can see that the rotation is actually changing here, right? So it's rotating, changing this rotation, and then for the player, if I move, you can see it's also changing this rotation, the Y rotation. So I can actually see this happening in real time, which is fun. But all these changes that I make while I'm in play mode will actually get reset the moment that I stop playing. So if I now stop playing, the value just becomes the one that I had before. So it's not permanent, it's just while I'm playing, which makes sense, right? Because we're changing the world. There's one thing that's missing here, and that's I can just keep moving up, 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 and I can sort of do this thing that I won't. It's already looking painful because I can't really do that in real life. I'm not sure how flexible you are, but this is this is outside of my bounds of possibilities. It's kind of fun, but so probably we want to limit how far we can go up and down with our head. And again, we can look at our camera movement here to figure out, okay, how high should that go actually? So if I look at the rotation, how high up should I go? Well, minus 90 is probably enough. And then how low can I go? Probably around 90 or so. So I have to limit the range that I can go here between minus 90 and 90. And the way that I do that in Unity is to clamp this value. So after I've set the rotation here, or I added the rotation to whatever I had before, I'm going to clamp it or limit the rotation. So I'm going to say, well, the X rotation is now the X rotation, but then clamped. So mod F dot clamp, note the upper cases of the X rotation. So take the X rotation and limit it to between minus 90F and 90F. So the values that I just checked. And look at how I did this. I know how to write this before because I did it, but I looked at the values that I want and then I typed them in here. So I sort of guessed the values based on what I saw in the view. If it turns out that I don't want to move up that high, I probably want to limit this to like minus 20 or something. But I check in the view first what that value needs to be. And now if I play here, you can see I can no longer move my head like all the way around. I can just move it a little bit. Now there's one problem with this, and that is the fact that this is actually dependent on how much the update gets called, because every time update gets called, I actually see this happening. This script gets executed, but that depends on the frame rate. So basically how fast or how slow your computer is. And that's not really what I want. I want this to be independent of the speed of your computer. And so the way that I need to solve this, I actually need to think about, okay, how many, so whenever I'm in update, how many frames or how many time has passed, and use that to multiply that. So what I'm going to do here is I'm going to add a value that's going to indicate the sensitivity of the mouse. So I'm going to write public float. And remember, if I write public, it's going to appear later on here in the script here. So I can write mouse sensitivity equals 100F. So I have sensitivity of 100, whatever that means. And now I can take this input here and I can multiply that with the mouse sensitivity and then multiply that again with the delta time. And the delta time is basically how many time has passed since the last time I called update. And this means that it makes it independent of how many frames per second that I run this script. So this is used everywhere because it's really important to decouple that from what I have. So this is the final script that I have. So make sure to add the mouse sensitivity and then time delta time as well. And then you can run it again, and then you can check. And if you feel that your sensitivity is too high or too low, you can actually change that value. That's the point. So going back to Unity, you can see that you have this extra parameter here, the mouse sensitivity, and you can change that if you feel that it's too fast or too slow. All right, so playing again, and now I can see, okay, yeah, it sort of looks okay-ish. Yeah, is it working?
Yes.
Cool. All right, so that's mouse movement. Our character is still paralyzed, but it can move. But this is already really useful because we can use it everywhere. We can use it every time. You don't only have to write it once. Well, this is actually the third time I wrote it already, but like you only have to write it once, and then you can just copy and paste that wherever you need the script for looking at a player. This is all you need. So in that sense, it's really useful. And now we're going to add a second script, which is the script to actually make the player move. And that script is going to attach to the player itself. So not to the camera, not to its eyes, but to its feet, to its body, right? So we're going to select the player here, and then we're going to add component. And again, we make a new script, so new script. And then the script is going to be called player move. Again, note we don't have any spaces inside there. The name is arbitrary, right? Because we can choose the name here. So I create that, create an add, and it's going to add that script here. And just as before, I can double click here or open it up and see what that script actually does. All right, so it's the same basic setup that I have here with start and update. And this script is actually, yeah, I would say the same sort of complexity than we had before. There's only one thing missing here from that player, and that's before I do that is I need to have a reference to a character controller. And this is kind of weird because you would think that an object or a component called character controller would actually control the character, but we have to do the input ourselves. So this is like it helps, but it doesn't do everything. So again, I'm on the player, I do add component, and I select the component character controller. And basically what the character controller is doing is it's doing the actual movement of the character and limiting that movement based on some parameters. For example, a slope limit or a step offset is going to define how the character can move upstairs and downstairs, or how steep it can take an angle. So if you're moving, if you have a mountain landscape, that can go like all the way up 90 degrees, or it can go like only 30 degrees or whatever. That's what the character controller is doing. It's limiting the amount of movement that it can do. And for example, if you're squishing against a wall, it sort of moves, it slides along that wall. That's the sort of thing that you don't want to program, and that's what the character controller does. But it doesn't actually react to keys, and that's what we have to do. So we're going to take our input and we're going to send that input to the controller and basically say, okay, move based on these parameters that I give you now. Okay, so back to our script. So we need to have a reference to that character controller. So here at the top, we say public character controller, and we'll call that one controller. So in Unity, all these things are typed, they have names. So in JavaScript, we would just write const or something. But here we have to write the name of the type of that value. So it's a character controller, and the name of it is controller. So this is the type, and this is the name. And then we're also going to keep, let's see how we're going to do that. Yeah, so in update, we're going to get our values for our whatever we use to control this character. And you would think, okay, I can use the keys here, so I can, I'm just going to check for if W is pressed, then we move forward. If the S is pressed, we go move backward. We can do that, that works. But in Unity, because we can have multiple inputs, we can just check for a certain input. And here, you don't have to do this, but in project settings, you can see there's this input manager here, and here you can see all the inputs. So here you can see, okay, the horizontal input, for example, how is that controlled? Well, mostly by the left and right buttons, right? Or the A and D buttons, or something else, or trackpad, or let's say a gamepad, a game controller. So all of these things are set up in the same way. So that makes it convenient, because that means that we can have multiple inputs. We can use a gamepad if we want, and that's just automatically supported. So that's why we like to do it this way. And so here we can say, well, the X position is the input, get the axis of the input on the horizontal axis. Oh, sorry. So this is the axis that I just had before, right? That I just showed you. And the same thing we do, but not for Y, but for Z, because we're moving. Remember, Y in our 3D world is up. So Z is our movement, our lateral movement, basically, side by side. Cool. So now we have these two movement parameters. And now we do the same thing as before. Note that these are changes in movement, right? They're not the whole, they're not like the where you are, but they're changes. So every time we hit a button, it's going to add to that value until we release that button, which is exactly what you want. So we're going to make a vector that's basically calculating where the movement is. So we're going to say move, and then we're going to take the transform, so the current location of our guy or position, remember the lowercase t here, so this is the built-in transform. Take the right value, because that's how we move, and multiply that by x. So multiply this this direction with x and multiply forward with z. So the z movement is in the forward movement, like this. So the z is forward and the x is lateral, so side by side. So this calculates how much we have to move in both directions. And now we're actually going to make that movement happen. So we're going to say controller.move, note the uppercase here, and then we are going to say move. And now if all goes well, yeah, I'll leave it open for a while, but it's not fully working yet. So if you want to test it, you will see that it's not working. We still have to do some things, but I'll let you type a little bit.
What are those zero reference or one reference? Yeah, at the top above the void and the public. And
oh, this one, I don't type this. This is actually
oh, okay.
Visual Studio Code trying to be clever. It's actually linked to Unity somehow. Although auto-completion doesn't work, so it's not very useful for me. But you don't have to type these. I just only type this part and this part. Now, going to our player, if you type this, you will see that our controller here is still set to nothing. So we have to drag in our controller. It would be cool if we could do this, and we can actually do that. So we can take this controller here and drag that in here, or you could just take the player here and then drag that in here, and it works the same way. But basically, we want our player move object to have a reference to that controller component. And now if we hit play, we will move, but probably way too fast. Or not at all. Oh yeah, yeah, way too fast. And only in one direction, what? Oh, oops. So I made a mistake here. So I did horizontal here and horizontal here, which of course doesn't work. So this one needs to be vertical. Because what you saw happening is that I moved in two directions at the same time, which is not really what I want. All right, so now I can move, but I'm just going really fast. And through buildings as well. So I probably want to be able to control the speed of my movement here. Is this working for you?
Yes, I'm also going through buildings and whatnot, so.
Yeah. All right, so let's limit our speed here. So we want to be able to set our speed so we can control it. So we're going to write public float speed, and then we set a default value of 12. Again, I did this by trying it out. And now we can take our movement, or move here, and now we can say move that by the speed by time.delta time. And again, this delta time is important because we don't know how many times update will be called. So by using delta time, we are actually basing it on the time that has passed and not how fast our computer is. All right, so going back to our game, we can move, yay. And now we can see that we can move our character here. It's kind of funny to actually see it moving around on the side as well. So this is the final code for the movement. Does this work for you?
Yes.
And note that, again, you have the speed control here, so you can make that faster or slower. So if you make that to 5, for example, and now you play your game, now the movement is much slower. Or if you set it to 50, you're like a race car. Yeah. One thing that's annoying to me is the fact that the cursor is still there, so I still see my arrow. Although, yeah, it just moves all over the place, so I don't really want to see that. And we're going to change that in the movement. So I come back to the main camera here, go to my player look script, double click. Note that I can also do that in project and then double click here. That's the same thing. So double click the script here. And then in start, where I had the print, so where it says hello from the player look script, I'm going to comment that out so I don't see that print statement anymore. And then after that, I'm going to write a way to lock the cursor. So it's basically putting the cursor always in the same spot and hiding it. So I'm going to say cursor.lock state equals cursor lock mode.locked. That's going to keep the cursor from just moving around and just leaving it in place all the time. And here I think autocompletion really helps. If you let the system autocomplete for you, it's easy. All right, so trying again. We see we don't have a cursor anymore, so now we can just move around freely, and then we can walk around our little city and have that influence, which is cool. You can walk in this little dark alley. It's awesome. All right.
My cursor it can look up and down, but for some reason it doesn't look, I can't change it, rotate along the X. I think I might have made a mistake.
Okay, let's check your script. So the looking, you can look in one direction, but not in the other one.
Yeah, I can look up and down, but I can't like shake my head left and right.
Mm-hmm. So left and right is the influence that you have on the player. So this line is what actually moves the player or rotates the player. So you should check what's happening here. And are you?
Yeah,
you have mouse X?
checking.
Do you have mouse?
Yeah, input, get access, mouse X, time, delta time. Making sure I didn't like have a typo or something.
Mm-hmm.
Yeah, mouse X, get axis. And rotation is minus equals mouse Y. I can't see the wall. Can I share my screen just to be sure?
Yeah, of course.
Okay. Okay, share screen here. You can see it, right? Okay.
Yeah.
Okay.
That looks good. Do you have a reference to, so you say you can't look up and down?
Yeah, let me change my window. Stop share. And then where is my, whoops, sorry, wait. Here. No. You know, I'm just gonna, there, okay. Okay, just play it. Ooh. Oh my. Ooh. Okay, so here, look. Ooh. So if I can't turn, like it's a bit locked. I'm not sure what's, like if I go up and down, no problem.
That works.
And there's left and right.
Left and right doesn't work. Okay, yeah.
Yeah, sorry, yeah.
Right, so can you go to your main camera and click on main camera once?
Okay. Right.
Yeah, and then here in the script, we want to make sure that the player, this is actually set to the wrong one. So the player, you have a slot for the player here at the bottom, Lucas.
Yeah.
On the right side, you have your properties. You have player, but that's, so you have script,
yeah,
player, main camera. No, you can open it again.
Oh, sorry.
Yeah. And then you have mouse sense, so your mouse sensitivity, but player needs to be set to the player object, not the camera itself.
I see.
Now it's linked to the camera, but it needs to be linked to the player. Because what we're doing is we're rotating the player, which means that we need that because if we move our player, we actually need to move the player based on that rotation that he's in at the moment. Otherwise, it doesn't rotate.
Ah, all right. Thank you.
Now, if you move, you should also move in the direction of the player, and it's a bit fast, apparently.
Yeah. Yeah. I'm sorry. I was troubleshooting a while ago.
Yeah.
But okay. Cool. All right. Thank you.
Yeah. But you can change the screen, so that's fine.
Yeah.
All right. Cool. So I still want to do a little bit of the visual styling. I had a lot more of that planned, but I just want to do the basics here. Specifically, what I want to do is add some street lights and then remove the normal lights just to have like a scene in the dark. So to do that, what I'm going to do is create, on my scene is create a point light. So I do light, point light, like this. And I add some point lights here. Make sure that the height is set to like 3 meters or something. So that's my street light. And then make a duplicate here and make a duplicate here. And then what I'm also doing is I'm going to turn off the skybox or make the skybox really dark. So I'm going to make a new material. So here in the project, create material and call that like dark sky. And then as before, for the shader, we don't want the standard one, we want a skybox, a procedural skybox. And here the exposure needs to be really low. So I'm going to do the atmosphere a bit thicker, but the exposure needs to be like 001 or something. So really, really dark. Now we're going to go into the details of the lighting. So if you don't have that tab anymore, remember you can do it in Window, Rendering, Lighting Settings. And so that's this tab. And here for the skybox material, we're going to drag in our dark sky. So everything's darker now. Now, because it's darker, we don't actually have the sun. So for the directional light here, which you have on the side, we're actually going to dim that down. So either you just click it off and you don't have any light anymore, or you change the intensities to something very low, like 0.1 or something. So then you have like nightfall, but not completely dark. And again, you can play around with these values to make sure that you have the correct setting here. And then what I wanted to do is I wanted to direct the attention to a specific scene. That would be fun, so you know where the player needs to go. So what I'm going to do is I'm going to select that house at the very end of my street, use F to zoom in. And now I'm going to add like a light here in the door, so you can actually tell that this is the place where you need to go to. So the way that I'm going to do that is I'm going to make a 3D object, a plane. Drag that plane, so rotate it this angle. So this should be at -90. And then set the scale, so with the the R, drag that down here, like this. And basically I want the shape of the door frame. So now if I move that into place, it's actually going to be inside of the door frame like this. And as you can see, it's a bit too deep in, so I want to move it like this. If you find your scene is too dark, you can click the light icon here to temporarily just have the normal lighting or lighting turned off, so you can actually see it much better. And I want to have it stick out a little bit and also make it a bit bigger here. Right, so I want to highlight that door frame. That's basically the idea. And now what I'm going to do is I'm going to make a material for that plane. So I'm going to create material. And this material is going to be called glow. I can drag that onto my plane here. So it's this plane, and I probably want to rename it to like a door glow or something. And then in glow, I'm going to set the emission to a certain color so that I can actually see the light. So here, what I'm going to do is, so I have the material for the glow selected. I select the color here. I choose this bluish color. And now this is what's called an HDR. So you can actually make it brighter than the rest of the scene. So this makes it emissive. So here for the intensity, I can actually crank it up to like something of 8 or something. And now it becomes its own light. I'm not sure how good we can actually see that. So if you move in our scene, can we actually see that already? Yeah, so we can see that we have something happening in the door, but it's not really shining yet. So we still have to do that part. And that's what I wanted to show. Right? Does this make sense? So we're going to do something special for this door. I'm also going to take my player and just move him a bit closer already so I don't have to walk over all the time. Yeah, something like that. So I can see the door frame as I'm doing my thing. So I have this door glow, and now comes the interesting part, I think, which is the post-processing. So now we can actually start adding, let's say, effects to this scene. And the way that we do this is we are going to go to the, we're going to add what's called a post-processing step. And to do that, what we need to do here is we need to download that first. So we go to Window, Package Manager, and we let it load for a while because there's a bunch of packages that it can load in. Some of them we already have, they're installed by default. But if we let it load for a while, we see that I have a bunch of packages. These are basically, this is basically the same thing as when we download packages from the asset store. So the one that we had before, the textures is already in here. We're looking specifically for this one called post-processing. These are our effects. So we're going to install these effects and let it do its thing. And then it's going to just import everything, I think. And it's kind of annoying that we have to do it this way, but that's the way that Unity works. It's not just hitting a button and having glow appear immediately. There's, I think, way too many steps, but yeah. Again, you can watch that later to check what we need to do. Of course, we're almost out of time. All right, so it doesn't actually influence anything in our scene, but we can now use that post-processing step in our camera. So we're going to go to our camera, which remember is in our player. We select main camera here, and now we add a component here called post-processing layer. So on the camera, so the camera is actually doing something extra here. And then it says, well, this is the camera, all right, that's good. And then the trigger, the layer is, okay, which layer is that post-processing on? Now, this layer doesn't exist yet, so we have to make that layer. Again, there's lots of steps to remember. So I'm going to go to Project Settings, go to Layers, Tags and Layers, this one. Open up Layers, and these are the default built-in layers, and we're making a new one called Post-Processing. All right, I close that down. So again, that's in Project Settings, Tags and Layers, this layer. Close that down, and now select Post-Processing here. Now something still doesn't happen. So before, in older versions of Unity, we can now start adding glow and things like that, but it doesn't really work here. We have to make an object for that. So we have to create an empty object here. We're going to rename that to Post-Processing. And that object needs to be post-processing, not layer, but post-processing volume. Again, don't ask me why we have all these weird names, but that's what we need to do. And then it needs a couple of things. First, we need to set it to is global, so it applies to the whole scene. And then we also have to set that post-processing thing to render in that post-processing layer. So it's basically an object that takes the whole scene and adds some effects to it, and then renders that in the layer, and the camera then adds that layer on top. I know it's difficult, but that's what we need to set up. And we still don't see anything because it's asking for a profile. So it's asking for another object that we don't have, which is our post-processing profile. And this is actually the part where we can define what we need to happen. So we have this new button, we'll click it. And now hopefully, yeah, oh, it's here. So this is our profile. I'm not sure why I put it here, but I'm just going to move that to assets because I wanted to have it here. So these are my profiles. This is what's actually getting applied in the scene. And we're going to make a very obvious one. So we're going to add effect, Unity, and now we'll choose color grading, which is very useful because it allows us to change the color of the scene. For example, we can select temperature here, and now if we move that, you can see that we have a more bluish or more reddish kind of look to the scene. We can tint the scene, we can change the saturation, so make it add more saturation or less, so it becomes more grayish. There's also the tone mapping, which is really cool. If we set it to aces, it becomes this really dark thing, which I like, and then we can add a bit of post exposure to make it a bit more, yeah, the way that I want. And then also can add more effects. So there's a bunch of effects that are really fun to play around with. The one I'm looking for is bloom. And bloom is actually an extra light. So I can add an intensity here, and you can immediately see what I want to happen, which is that this light here becomes highlighted. I can also add a threshold, so you can indicate which parts I want to bloom, but by default this is set to 1, which is fine. I can also do the color and things like that. But this is basically where I want to end up. So now if I play the scene, I'm going to also maximize it so you can see it a bit better. If I play the scene, you can see I immediately have this sort of very moody scene where it's obvious, sort of obvious that there's this one highlight thing where I have to go, which is really cool in games. I think that it's super obvious where you need to go, and so you see that it's highlighted here. It doesn't actually reflect off of the rest of the scene. It's only like the glow is there, but it's not lighting the steps, for example. So a trick that you can also do, because this emission texture is not actually lighting the rest of the scene, it's just there, is to add a little point light here as well. So you can do create light, point light, and move that light. Oops, not here. But move that light like where the door is. So if I move that light over here, whoop, you see it's a bit better already. Maybe down, and maybe not like in front of the door or something. That makes more sense. Here, now I get some extra light. Maybe also make it a little bit bluish. Maybe not so much. Yeah, and now if I move to the scene, you see that I also have this light, which sort of makes sense because it sort of emits from the door, so it's a bit more clear. So I can add extra lights, and you can't really tell that it's not from the glow, but it's like an extra light. You don't actually see the rest of it. All right. There are much more options to the post-processing. Again, clicking here. So there's color grading, there's bloom, there's chromatic aberration, which is fun. It's basically shifting the colors. So I'm not sure if you can tell on the video, but on the sides of the building, like here, the colors are shifting a little bit. So if you look at the side now where the door is, you can see that it's sort of shifting the color. So it sort of makes everything a bit weirder. There's like vignette options as well. So there's all these kinds of fun options to play with. So it's kind of annoying to set up because there's lots of steps, but once you have it set up, I think it's really, really cool to have, and it really adds a lot to the scene. That's it. There was one more thing, but maybe that's already too much. You don't have to follow, but I just want to show how that works, and that is sound. So if let's say that I want to add a sound here. So in the door glow, I can add an audio source, like new audio source here. And now I can import a sound. So import new asset. I actually had a sound from somewhere else. Unity assets, this one. So it's like a bubbling pot. Not sure why it's that sound, but whatever. So I just have a sound here. I can add that as an audio clip here. And now if I just play, the sound is everywhere, which is not really what I want. I want the sound to be inside of the door frame. So here what I can do is I can set a 3D sound level. So first I have to do the spatial blend, meaning this sound is a 3D sound. And now I can change where I want to hear it. So what's the minimum distance? How close do I have to be to hear it? And what's the maximum distance? So maybe this one is to, I'm just going to make it really short, 0 0.1, 0 0.223. And now I don't hear the sound so much if I'm further along, but if I'm closer, I can actually start hearing the sound. So again, it's something where I'm drawn to this door to actually hear that sound. Oh, I actually also have to loop it because this is repeating. So I can do loop here and then play around with the values of that sound to make these sounds move into the space.